See if we time that just right, where we both hit
Yeah.
it at the same time. Let's see if it lines up.
I would imagine it will be close.
Ladies and gentlemen, welcome to Universe Sandbox 2.
With Mark D'Antonio and Keith Ickes. Now, batting.
We're gonna smash stuff.
We're going to smash planets.
We're gonna take a Nibiru and we're just gonna throw it into the solar system.
No, the heck with that. We're going to make Nibiru. Then we're going to smash it to a billion pieces.
Let's do it.
Okay.
Let's make Nibiru.
We will do that.
Just so you guys can see how far away you guys would be able to notice this thing.
So, first thing I must do is open up a new solar system. And I shall find my solar system. Gotta find it.
You sound like a demon.
Well,
Jesus.
We are going to be destroying a solar system, so...
Very true.
So we have to
true.
do this, yes. Okay.
And sorry for everybody for the impromptu stream. You know, we streamed 9 hours in the last 24, and we decided just to keep going and do one tonight. The moon don't come up till way later, so we're not even going to bother with that. Paul's taking the night off. Me and Mark decided we wanted to play in Universe Sandbox, and oh my Lord, look at all that.
And we're inviting you to the sandbox with us. Yeah, there we are.
By the way, hey Rock, tell me how the audio is. Supposedly I got this fixed, and neither me nor Mark should be peaking or getting distorted in any way. Let me know. You can tell we've been streaming a lot because usually within like the first 2 or 3 minutes, there's like 30, 40 people. Like tonight, there's like 5.
Well, you got a lot of people that are on vacation too.
Very true. Very true. Are you making Nibiru?
Not yet. I'm actually... See what I did? I made all these really cool stars based on chemistry. I actually made a bunch of different stars here. I made like...
Say it with me now. Nibiru.
No.
Let's go. Man,
I will not say Nibiru.
Nibiru. Yeah, and also it's just going to be me and Mark making voices, and it's going to be a bunch of dick and fart jokes tonight.
Oh,
and...
stop. It is not. I don't do that.
Okay,
stuff.
With me, it's going to be a bunch of dick and fart jokes tonight. With Mark, it's going to be more like keeping it professional. But
I'm going to put this
that is
O-star.
all. That is why I do. Oh, I forgot. I did put this stream 18+, so that might be another reason.
Yes, I'm putting this O-star right next to the sun. So we have the sun. And
it's Keith's Unprofessional night.
Yeah, right? Now let's see what happens if you send up an O-star in orbit around the sun.
Where's the paper boy?
Oh,
what are you doing?
I put an O-star in the solar system, and the look at that. There goes Mars.
And
look at everything.
Destroyed humanity.
Look at everything go. Shoo!
Oh, Jesus.
Holy Christ! Look at that go. Boom!
Yeah.
Yeah. Okay. And of course, those are asteroids out there. I made an asteroid belt and stuff. That's so cool.
Looks like a pack of gnats.
It does, doesn't it? It's like summer in Maine. It's like...
Hello, Greg Brown. Welcome to the channel. P&K. We're actually dual streaming. We're simulcast tonight on P&K and Mark D'Antonio's channel, SkyTour LiveStream.
Yeah, I'm both.
We're having fun. We're going to start smashing stuff together here in a little bit. We're going to build Nibiru just so you can see how much it would affect our solar system before it even arrives. 100 years, 2, 3, 5,000 years.
Okay, so we're back to a regular solar system now.
Because all we're going to do is prove that Nibiru is full of shit.
Oh, and there's how we're going to do this.
Yeah, I said it. So what?
That's like Mark Levin. That's right, I said it.
I said it. I'm not afraid to say it.
Norton, you are a mental case. Yeah, we'll just put stars in the background.
Dude, I just did that voice impression. I thought I sounded like Larry from the Three Stooges. Yeah, I said it. I don't care.
Not really. In your head, you did.
You know what? The long drives back from Maryland, I've been working on my Jesse Ventura impression.
Oh, no. Well,
yeah, I've been getting good at it. Like, I've been confusing myself on the way home. Tell me how much time I have.
Well, people definitely have to know how Jesse Ventura sounds before they can say, oh, yeah, that's a good job.
He's like deep, and he over-enunciates.
Yes, he does. Yeah, he's like, I remember when he went to the, in Colorado, he went to this nuclear lab,
nuclear energy actually lab. Actually, no, it was the Department of Energy laboratory. He's like, I'm Jesse Ventura, and we're at this nuclear power facility. Wait, what? No? Oh, okay. We're at this facility that does stuff with, like, nuclear stuff. Wait, what?
Yep.
Oh, no.
Ladies and gentlemen, I don't know why I'm here.
We're at a Department of Energy facility here in Colorado. Yes, and...
Sometimes I left my brain back in Colorado.
And all they did was kick him out. That was the whole show. They kicked him out. So you couldn't stay. Go home.
I remember seeing a clip of like Jesse Ventura and like who was it, David Icke going at it? Like Jesse Ventura was telling him he was full of shit, and David Icke didn't like it, and it was funny.
That's funny as heck.
I think it was actually on Jesse Ventura's show, that conspiracy theory show. Like he confronted David Icke at one of his live performances or something. How do you know that? What makes you think that is the key?
Okay, we're going to add a planet that's 10 times the mass of the Earth. And we're going to add it out in the Kuiper Belt.
Add it way past Pluto.
Well, the Kuiper Belt is there. But, you see, if we, add it far, far away, well, we can do that. Let's put it here. Just this. Yep. Okay, so here we go. If you look, it's actually at its distance here.
Is there a way to take off like asteroids and stuff so people can see the planets and just so they can see what the planets do as this thing approaches?
I guess so, but
it's up to you.
But only the planets make trails. The asteroids are not gonna. All right, so here we are. We're gonna be here. We are in the outer reaches of the solar system. Here in the Muppet Show.
Near the blue dot.
Nowhere near the blue dot. Hello, Miss Piggy. Oh. So, okay, so we put it out here, and there goes Planet 9. And
hello, Biggie.
There's Planet 9 way out here.
There is Planet 9.
And now let's increase the timeline here and see what we get.
Now watch, people. Watch what happens when this thing gets even remotely close to our solar system.
Well, it's in a circular orbit, so it's going to just orbit.
You son of a bitch. I thought we were launching it into the solar system.
Oh, is that what you want us to do?
Well, yeah, I don't want to put it in orbit.
Okay. Then maybe we should remove it like that.
All right.
And we shall put it back in. And we shall launch it, shall we?
What's this look like?
Is this going to be a 10? We're going to make it 10 times the mass of the Earth?
Well, let's see. What is a brown dwarf? Because that's what they all claim Nibiru is. It's a brown dwarf coming at us, going to kill everybody.
Okay, well then that would probably be something like this one. Or close to it. So let's do this. It'll be 51 Pegasus, and we'll do... we'll send it toward the sun, right? Should we launch it? We'll launch it right here.
Right towards the sun.
Yes. Here we go. Bing. There it goes.
Bing, bang, boom.
There it is. It's going on. It's now heading in. We'll come back to you in 4.3 million years when it finally gets close. Here it is.
It's 51 Peg B.
Right. And
heading towards our solar system.
Yes, and we can't really go... in this simulation, I can't go up past 3 months per second, so it's going to take quite a while. So I need to remove stuff. You're right. How do I get rid of the asteroids? How
Can we remove space?
That's funny.
I'm sorry, but every time I hear Jesse Ventura, he always says something stupid. And totally throws, like most times, it's
what if we just remove space?
Yeah. I wonder if there's beer on the sun.
I heard there's 42 civilizations living inside our sun. Is that possible?
Even I find that retarded. Okay. So what did you remove?
No.
I'm trying to figure out how to remove stuff. See, because we got all these stuff here. How to remove asteroids? I'm not sure. I'm not sure how to remove
how
stuff.
fast Mercury is.
Yeah, but see, we're already redlining here. Or down the lower left, you see the red steps.
Oh, yeah.
We're redlining because I've got all this other stuff going on. I got to get rid of everything but the planets. So I don't know how to do that. So we may have to come back in and do this. Because meanwhile...
I'm trying to remember.
Meanwhile, 51 Pegasi is still zipping toward our planet at ungodly speeds that will still take it forever to get here.
Still, you're going to see orbits start to twink. They're going to start going everywhere.
Yeah, maybe I should have. Let me see. I'll let this keep going here, but I'm going to see if I can find another rendering of the solar system.
Oh my!
And try that. I don't want any of the.
Hello, Nancy W.
Uh-oh.
I believe it's a conspiracy theory.
I have no idea what's going on with the stream, so
I don't want us looking at this stuff.
Jesse, stop. You know, we invited you. We invited you on the stream to be, you know, a gentleman, and instead you're being a jerk. Now, cut it out, Ventura.
Bah humbug. You know just as well as I do.
I don't think you know anything.
Yeah, probably not.
So, I'm looking here. I don't know how to get rid of my stuff, my asteroids. I want to get rid of the asteroids. I want to make it, slim it down. I want to slim down the. I want to
make our asteroids skinny.
That's a good idea, Chris.
It's so funny. You named your stream Planet Destruction. I forget what I named. Hold on. What did I name mine? Oh, yeah. Universe Sandbox Session. Let's smash stuff together.
I guess I'm probably going to get, like, banned from YouTube again because I said destruction or something.
You're going to die.
Oh, there it is. Look, there's 51 Pegasus. Look, hey.
They're coming for you.
Look at that. This is its projected path, that orange line. Let's follow
What is that we're looking at?
We're looking at a brown dwarf. See how it circles in toward the sun? It's starting to. That's the path it would take. That it's going to take. And this line here is the vertical line above the plane of the solar system. So when you bring it down, okay, we see the plane of the solar system. You see right at the bottom there. So when I go here, we go here. I'm level. So it's coming in from a high elevation.
I ain't high. You're high.
Yeah. Okay. Yes. We know Keith is ridiculous.
Yeah.
Exactly. Yes, indeed.
What are the odds of finding an exact system like ours with a planet in better shape than Earth? Very high. How about that?
Yeah, actually, it's not unheard of. Actually, we would probably find a planet that doesn't have problems with the magnetic field around the Earth, such that, its Earth, such that ultraviolet light could get in. There's actually we found one exoplanet that actually produces, no lie, sunscreen in its atmosphere.
Yeah.
Only problem is, of course, we couldn't breathe that. So, but it's a kind of
built by the Illuminati.
Exactly.
Is it like still moving, or we're just moving slow?
It's maxed out too at
Wow.
2.5 months per second.
Whose bright idea was it to put that thing way out there?
I would believe that was yours. But you know what? We're gonna get rid of
bad.
it. We're gonna get rid of it, and we're gonna move it to boom, and we're gonna start over.
It'd be nice if you could like drag them. You know, just kind of like click on it and drag it closer. It'd be a nice
But
feature
see,
to have.
this is the problem with that though, is look, there's Sedna.
Physics, I know.
Yeah, well, yeah, and it's trying to do calculations, and if you make it so that it can't do the calculations, well, then it's going to become inaccurate, and when it becomes
just needs to
inaccurate,
do its job. Shut up, Jesse.
yes. All right, so let's do this again. Let's bring in. Well, let's just bring in the solar system again, but maybe. Yeah, I don't know how to get rid of the asteroids.
There's like a
Some kind of setting to get rid of the minor planets, I know. Maybe, let's see, sim.
yeah, I don't remember. It's been so
View.
long since I actually worked the controls of Universe Sandbox.
Yeah, I know.
Isn't there? There's not a pre-loaded one without the asteroids and everything, right?
Well, that's what I was trying to find.
Oh, should have been paying attention.
Shut up, Ventura.
That's gonna be the I'm gonna make that a T-shirt.
Should have been paying attention.
It's just gonna say "Shut up, Ventura."
That's funny. Okay, let's try this. There's nothing under that.
Don't tell me to shut up. I was a wrestler.
You're a wrestler. Okay, let's.
Sound like Skype signing off.
Hurry. Actually, it sounds like the door's closing on the spacecraft in what was it? Hitchhiker's Guide to the Galaxy.
Dude, did you ever see there's
Marvin,
a video?
Remember Marvin, the depressed Martian? Not Marvin the Martian, but Marvin, the depressed robot.
Where this guy was back, he was on a roller coaster, and he kept fainting. And every time he fainted, the person put the Windows thing on it. So it's like, like, and he fainted like 10 times. And every time he came back, it played the Windows boot noise.
That's funny. Where is
Dude,
that?
That's freaking great. I gotta send you that.
Yeah, where is it? Is that on
I don't know.
YouTube?
I saw it when I was going through Facebook, and I laughed so hard I almost pissed myself.
You are
Like,
part
every
of a
time he
rebel
fainted,
alliance and a traitor.
That's funny.
I don't find that funny. Shut up, Ventura.
Yeah. Okay, let's see now. What else can I do here? How can I just... So, really, I get into the red zone.
That's how the SEALs do it.
Well,
What
see,
is going on right now?
I have it up to... if you look down the bottom here in the lower left, you can see the scale is now 1.3 years per second.
Okay.
So...
Where's the...
I didn't launch anything yet. I'm just doing that. Now, see, what happens is when it does that, it gets inaccurate. It gets much less accurate. So
Well, that's okay. We're not in this for accuracy. We're just doing it for science.
I know. I'm doing it for science. I think they don't worry about him. All right, so here's what we're going to do.
Make no sense.
We're going to launch Pegasus 51 Pegasus B from like here. But we can
right beyond Pluto.
No, what that's you're the one that said that before, and guess what happened?
Like right beyond. Like I'm talking like literally if Pluto
All right, tell
was
you what.
a mattress store, make Nibiru the other mattress store across the street.
All right, well, I can do that then, but I think it would be kind of cool if we launched it right in the vicinity. There's Pluto. Okay, there it is.
Screw it, kill everybody. Do it.
Well, no, just launch it from like this location, like here. See if we can get closer.
Do it. Do it.
Don't do it. Don't do it. Here we go. Oh, you did it. There it goes.
There she is, Miss Nibiru.
See, now it vanished because of the fact that it's actually not really that close to Pluto.
Okay.
See? And now we're only going days per second here. There it is over here. Okay, and I'll just kick that up so you can see it.
Okay, I like what you've done there.
Now we're going to go down here. I'm going to increase the rate.
Increase the rate.
All right, there we go. Now we're going some years per second here. Okay, we're doing a year per second.
Okay, it's coming into Pluto.
It passed Pluto's orbit.
Past Pluto's orbit. Now watch, can we get a top view of the solar system?
Yeah, we can.
So we can see how it's going to flunk it all over.
There it is.
Look at what's happening, people. Look at the orbits. Look at what's happening.
Yeah. Yeah, look at that. See, it's getting drawn. Yeah, and now it's accelerating as it gets into... I have to slow this thing down. Hang on. I'm going to stop it so we can get close to the middle here. And now as we come in, I'm actually going to... I actually want to center on it. And let's drop it from years per second to some months. Let's say not 2 days per second, but I want to say, well, what's 2 days per second do? Okay, it doesn't do much. Let's just accelerate until it starts showing something.
A little bit. I wish they didn't have that like sliding thing on the days and seconds. Like I wish you could like set it just at points. You know what I mean?
You can. You can click on this right there and make the change direct.
Oh.
Now here we go. So now we're doing 15 days per second, and I'm going to bring it down. Let's go like 2 days per second. And now as we get in close, okay, first of all, 51 Pegasi is actually, it's literally 146 times the size of the Earth. Not, well, mass.
Which is what a brown dwarf would be, right?
It's definitely a very large planet. Yes. We should compare it to Jupiter so you can see how it looks compared to Jupiter, but we'll do that after.
It's almost as big as my house in Mexico.
Ventura is a madman.
Shut up, Ventura.
So now let's just go a little faster here. Let's do we'll do 3 days per second. That's good. Now watch.
Oh, it's already going goofy.
Yeah, it's going goofy now.
It's going goofy.
Now you see it's coming through the asteroid belt. And it's taking it. Right, you know what? I'm going to pause. And I'm going to take the view. And do the background. And make it just stars. So we don't have the galaxy graphic causing us issues. So here we go. So
now watch what happens.
Watch it happen. One ping only. Now see, it's arcing up into the solar system, by the way.
Yep, it's coming up into
right.
the
So if we look at the plane of our solar system, we should notice some warpage that's occurring. So there it is.
And hello to Rod that's in the chat. And
Serling? Rod Serling is here.
This is Rod Sten.
Ah, okay.
That's over.
I'm not
looking
looking
at the P and K. I'm kind of bouncing back and forth between chats.
Mm-hmm.
Look at that.
Yeah. And see, the subtle changes that occur when this happens is something that we wouldn't necessarily see right away, but you can see some things have changed to the level playing field of the solar system. I want to take a look at 51, and I want to see what its mass is. It's 146 Earths. Let's see how much it is in terms of Jupiter. So in terms of Jupiter,
let's see what it looks like when it bashes into a planet.
Look at though. See, it's 146 times the mass of the Earth, but look at it's only 0.4 Jupiters. Okay, it has to be 80 times that to be anything substantial. I mean, to be a brown dwarf. This is just a hot Jupiter. Okay, in terms of its mass. So in terms of size of Jupiter, okay, it's only just under 1.5 times the size of Jupiter. So you're not going to see much happening.
Let's speed it up.
Well, I don't not necessarily speed it up, okay, because this isn't even a brown dwarf. If they're saying Nibiru is a brown dwarf, we got to make it. We have to make a brown dwarf. So
I thought that's what we were doing.
No, we use 51 peg. But I'm gonna take us out of this and make a whole new one again. We're gonna load. Don't worry, we saw
breaking news, guys. Mickey Mouse just broke up with Minnie.
That's funny.
Yeah, he found out she was fucking goofy. Drudge report.
Yes.
I tell you.
Okay. Fail. Oh.
Admit it. It was a good joke.
Fail.
I thought it was great.
Okay. Now, here we are.
I heard you laugh at D. Antonio.
Well, I only laugh because you said a swear word, and I'm always tuned to laughing at swears.
Yeah, that's true.
It's just the way it is.
It is.
Okay, so now let's actually let's go add a brown dwarf. Okay, this is 13 times Jupiter. I'd like to change it. Let's do this. Let's see if I can. I actually want to change this. I want to change this around. So, let's see what else I got here. I can throw basketballs and tennis balls. You wouldn't notice those. Okay.
I'm gonna sit here and wait for explosions.
I know. Don't worry.
They're gonna happen soon.
We're gonna do it. We're gonna do it. I'm just gonna. I think there's a.
Oh no, the solar system's already going crazy.
Well, it did before. But here's what I want to do. I want to try and do something here. I'm trying to get the properties of this. I don't remember how to do this. See, I want to take the this 2 mass.
Mark, did you put your stream on 18 plus too?
No.
Okay.
Should I?
I'll calm the F-bombs. No, I made sure to put P&Ks on.
Oh.
I wanted to make sure because I was like, you know what? After 9 hours of streaming in the last 24 hours, there's going to be some curse words that are going to slip on this last stretch. So I just put up to 18. I was like, not even worried about it. So anybody listening to P&K, if you don't like curse words or a little bit of adult humor, here's your warning that may creep in tonight at some point. Not intentionally. Possibly intentionally.
Okay,
but not really.
I made this 65 Jupiters so that it's a brown dwarf.
65 Jupiters. All right.
Yeah. What's a brown dwarf? Hey, where's the hell going? What the hell?
What the hell
What's
just
going
happened?
on?
It just did a 90, man.
It did. It did a non-ballistic turn. I don't know why it did that.
Physics.
Yeah. See, you can see the line below the solar system, the level below.
Because space is a simulation.
Actually, I want to...
Shut up, Jesse.
I want to save this. Okay, now it's coming back in. Look at the sun. See the sun moving?
Yep, look at the sun.
Look at the sun's moving like mad.
Would you look at it? Would you look at it?
That's it. And now...
There it goes.
So it's coming out. It's going out of our solar system.
Wow. It looks like a flower budding towards the sun.
Now see this right here? See this curve?
Yeah.
That's the direction the sun just moved.
Yep.
If you don't think that's noticeable, then I'm sorry. And by the way, notice the plane of the Earth has also changed. Okay, we're no longer in a plane with Venus.
Oh my Lord! Look at Mercury.
Yeah. Yeah, Mercury has made some... Well, actually, Mercury's relatively the same.
Mercury's reacting to our sun.
Yeah, I mean, they're all spiraling along with the sun, but the fact is, okay, look at this.
Where'd our nib go?
Where'd what?
Where'd our nib go?
Oh, nib. Oh, that's up here. Right there.
Oh, he's arcing that way. Okay.
Yeah. And you can see the projected path takes it back around this way. So if people think that we're going to get a Nibiru in this solar system that goes unnoticed, well, then they got another thing coming.
Look at Saturn. Kind of okay. Leaning a little bit inwards.
Let's see. How was it looking? Not sure. Okay, Jupiter's the biggest biggest gravity hog in
Dude,
mass
that looks
hog.
like such a cluster.
Yes.
Holy moly.
It does, because you can see as you zoom in, okay.
Look at how much the sun has moved.
Oh, yeah, it's moved quite a bit. See that arc? It came from before that, and it fades away.
Our sun is growing a tail.
Yes, our sun is moving.
And what is it? You're at days per second? So this is only days?
This is at 13 days.
You're looking at 2 weeks
second.
every second, pretty much.
Yeah, that's right.
And that's the amount of stuff going on.
Yeah, and the terminal approach of that thing, yeah. And then when it's up there, and look at that, it's way out there now. And
is that what we call it, the furthest point? Is that a perigee? Or is that a apogee?
Apogee. Perigee is closest. Apogee, away. Think of away. So.
See, I'm smart.
Look at Jupiter. Jupiter actually went like this, and then it's spiraling down. Okay, but of course, it is following the sun. And its orbit is changing. And the farther away the planets are, the less that's noticeable. And you can see, though, how much Jupiter's angle has changed. Now, if the sun were to slow down and stop, then there would be a return to normalcy. But from within the solar system, the planets would probably look not right to each other, because, of course, you can see that as we close in here and we go to the plane of our system, say, like that, look how much Jupiter changed. Right, Jupiter's now down here, and you can see that this is the plane of the solar system, about there. So you have to come down here and notice that Jupiter's now got a negative elevation, negative inclination, I should say, to our plane of the solar system. And that's something, and so does Saturn, by the way. So that's something that would be immediately noticeable. And here's the thing. Let's do accelerate this and see what happens.
Do it.
Now let's go to 4 months per second. All right, and let's zip around. So now there comes 2 mass again. Okay, It comes in one more time. Here it is. See? It went around and
There
it's
it comes
coming back in again.
screws everything
And then
up.
goes zipping away. And look what happens. It pulls the sun a little bit. See that tail now? See how the corkscrew happened? That corkscrew is normal.
Everyone loves a slinky. Everyone loves a slinky.
It walks downstairs, a loner in pairs, runs over the neighbor's dog.
Oh, what?
It's log, it's big, it's heavy, it's wood. It's log, it's better than bad, it's good. Everyone
It's
wants a
good
log.
as a food, baby. What was that just went flying across the screen?
Now there's new log for
Did
girls.
we just lose an asteroid?
No.
Someone like flying across the top of the screen.
Here comes 2 men. There goes Palace. See, Palace is up there. See what's happening? See all the turmoil that's going on here? Something like a Nibiru that's in our outer solar system that comes back every so many thousands of years, okay, it's going to cause tremendous problems in this solar system. And it's something that I don't think that people who don't have a whole lot of science background can really see. Because the problem that they're missing right away is we can tell where our sun's moving. We can see how we can get a figure about how it's moving. And it's not moving in any way consistent with a brown dwarf being in our solar system.
Made our sun look like a bed spring.
Yes, it's a slinky. Now go to sleep, Ventura.
The slinky was invented by the Illuminati.
And here comes that little 2-mass planet one more time. Remember, we launched it, so
There we
it's
go.
coming in.
Yep.
So now it's coming in again. And as we close in,
And
let's see.
it's Mars. Run for your life, Mars.
No. That's funny.
It's going after you, Mars.
Well, let's actually, I want to take a look at it again because there's something I want to talk about here. This is cool. So it's 65 Jupiters, okay? That's a pretty good mass. And in terms of temperature, this temperature is a temperature that's actually what the original 2-mass is the system by the 2-mass of the telescope that found it.
Where is Mercury still there, or am I just not seeing it's going too fast around the sun?
Yeah, it is. It's made this white line.
Oh, okay, that's
See?
what that one
See it?
is. Wow. Now look at those orbits, people.
Yeah, we've accelerated obviously. So, but now we come down and
Here it comes again.
yeah, it's in an orbit.
Here
I
it
put
comes again.
I put it in a high elliptical orbit, just like they say it is.
Oh, Mars, you're right in the path again. Run, Mars.
Well,
Jesus.
He's not seeing in 3D. See, it's actually kind of low. But
Allow me to be dramatic.
oh, you may go ahead. Be
Let him
dramatic.
be dramatic. That's what he needs. Shut up, Ventura.
So let's see if we can accelerate. We're pretty much stuck at 3 months per second, 2.5 months per second right now. But keep in mind, 2.5 months per second, and it's only taken us about 45 to 50 seconds to get this thing to come around through each time. So over the billions of years, this thing would have swept out asteroids. It would have swept out all kinds of other minor planets, and it would have messed with the orbits in a big way. And
it's going to smash into something.
well, I want you to take a look at what happened to Jupiter. So look how close Jupiter got, and now look what it's doing. See what's happening to Jupiter?
Mm-hmm.
So that's a bit of a problem, okay? And Saturn, notice Saturn. Saturn was never this close to the sun, and now it's out here. So
May I make a suggestion to you?
you may make a suggestion.
I would, if I were you, I would just shut down any programs that you're not using currently, if you have any open.
I don't.
Because I know when you move a lot on the screen, your audio starts breaking up, almost like it's your computer.
Oh, yeah. Well, you know what that
struggling.
is?
Just
That-
to give you a heads up.
No, I appreciate that. That's unfortunate, but that is indeed comes with the territory. When I go like this, it's like, and it's just because there's a lot going on. But
Yeah, I just want to make sure.
Yep.
If there's any, because I shut down. Well, I still have the 2 videos rendering in the background that I got to send off to Stanford, and then,
Yep.
You gotta love that WWE.
Shut up, Ventura.
Hey.
But check it out. Look at the orbit of Jupiter is now becoming more and more elliptical. Do you notice that?
Mm-hmm.
Yeah. That's the influence of repeated visitation by a
Saturn.
planet. Yeah, and Saturn's closer here.
Is doing okay.
No, it isn't.
Notice it's okay-ish. I mean, it's still out a good
Look
way.
at that. It's from here to here to the sun, and from here to here in its orbit. Look at that. It's 3 times further away at the far end of its orbit.
I was following the wrong line.
Yeah, it's the yellow line right there.
I don't even like yellow.
And here comes
Shut up, Ventura.
here comes 2 mass again. Yeah, its orbit is definitely evolving over time.
Yeah, it's getting way smaller, man.
It's evolving over time. So maybe we're going to see
we are going to kill everybody.
well, let's see. Would the introduction of a high mass brown dwarf, look, there goes wow, look at that right down there.
No, eventually in time we're going to kill
that
everybody.
asteroid took off.
Yep.
It got an interaction that it didn't like.
He said, I'm out of here, dude.
You know?
Screw this, it's getting crazy around here.
Nobody saw me do it. You can't prove a thing.
Yeah. That
Hey, Homer.
that surely is a pleasurable sensation.
That didn't sound like Jimmy Stewart.
You don't have anything good, do you?
Mary.
What's going on with this
How much is the fish?
Jupiter? Just the fish.
Yeah. Hey, look at this. So now we're coming.
Yeah.
No, let's come in here. Let's just have some fun here.
Oh, here it goes again. Here it goes again.
Yeah.
Whoa.
Whoa.
Run, Juno.
Yeah, I
Oh,
don't
you
think
stopped it.
I did for a moment because I want to follow it.
Okay, it's not near Juno. Okay.
Yeah, see, here we go.
Juno.
So here we go, and we're following this. We're
That
following
just
it.
scared the crap out of me. I was looking at the screen like all close, trying to see what the lines were. I was this big yellow-red mesh just comes flying at my face.
Oh, you should be afraid.
Jesus.
It's 65 Jupiters in size.
Yeah. Looks like a pleasurable ice cream cone.
Oh, is that a lollipop?
Lollipop, lollipop, oh lolly, lollipop.
Lollipop. Okay, so now let's see. It's coming down. So are people bored by this yet?
I'm fairly entertained. I think that's all that matters.
It is, because if you're not entertained, you like go down these other rabbit holes. But you know, it's okay.
I'll tell you what. Let's do this. Let's speed it up and let's just
Well,
let's
this is as fast as I can
just-
go. Remember? Well, actually,
is it?
let me
I
actually
thought you could go a little bit faster.
let me try going
But if
out.
not, that's cool.
Let's try going out and see if I can do anything. Well, I can get the 3 point. No, that's months
Nah,
per
it goes back
second.
down.
How'd that happen? Well, how about
That's
if I
cool
go-
though, because look at that. I mean, it almost condensed everything.
Yeah. Well, I'm zooming out.
No, I know that. I'm just saying it. We know from what it looked like
Oh.
when we first started, before we even
Okay.
interjected to Nibby.
Yeah. So you see, this is a solar system in decline because, again, you look at Jupiter. Jupiter's orbit is now just really torn up. I mean, little by little, okay, you'll see now Jupiter's orbit.
There is no more plane, if you know what I mean.
I do know what you mean. That's exactly right. If we look at the orbital plane, okay.
Hey, that's where I live.
Yeah.
Shut up and
That is exactly. But let's select Jupiter for a minute here. Just go there. There's Jupiter. Now, if we look at what we call the orbital plane, you'll notice that Jupiter used to be in a plane with the sun, and I'm going to stop it here just so I can grab the sun. All right, and maybe not. I know I have it.
bash it.
Oh, I guess I got. What's going on? Well, I don't get it, Mary. So,
This program's being kind of a prick.
yeah. So here we are. So here's the sun, and you'll notice now, okay, the plane that we care about is the one with the Earth, which is right here. But now you look at it, and of course, as the sun is moving through space in these awkward ways, look at that. You know, it's every time it comes around, every time 2MASS comes around, the sun gets yanked in yet another direction. See that? We would see that. I want you to notice Mars' orbit now. Look what happened to Mars. Mars is going really fast. It's in a highly elliptical orbit now.
Go home, Mars. You're drunk.
Go. So now we check out Mars. All right, and if we look at Mars in detail now, I wonder if it'll show us anything new. Now, as we accelerate, let me just get the sun back, and we'll just keep Mars focused here. Do this, okay? Well, never mind. We'll just do this. I want to show you this. So now, see the temperature? Minus 115, 112, blah, blah, blah. Here we go, okay. And then as Mars comes in, whoa, look at that. Mars' surface, as it rounds the sun in this new warped orbit, is 201 degrees Celsius. Okay? That's uninhabitable.
That's the temperature of my bath water that I had in Nam.
It's uninhabitable. So this is actually kind of a tough call, right? I mean, we don't have a solar system anymore that is...
No, we just got a freaking mess.
Yeah, and all because we introduced a variable, an additional object.
It's like, oh, this is a lovely place to die.
Yeah. And every time 2MASS comes down, it
I tell you what, they're going close so we can see like how close these planets are actually getting to hitting one another. Because they are, some of them are crossing paths.
Not sure if that's true.
Well, I see. Well, then again, it's really hard to tell when you don't have a plane because we screwed it all up. But
yeah,
still, you never know.
Yeah,
I still think that cool. Like that view is the coolest.
Yeah,
just because you can see everything. Just
you'll notice on Mars. Okay, you'll notice that.
Oh wow, what was is that? Oh, okay, that's Mars orbit you have highlighted. Okay,
yeah, this is.
I was trying to read it. I'm like, what is that? As it comes by real quick.
Well, I'm going fast, so that's why.
That's cool. That's cool.
Right, and then zoom.
And there it goes.
Yeah.
It's making a flower. The flower of life.
Yeah. Yeah, but if you watch the planetary models within this program, you'll see that the planetary faces change, you know, with their seasons as they get closer to the sun. You can see what that temperature is doing. Let's actually look at the Earth.
I lost it. I lost Nibiru.
Oh, that's because I'm zoomed in.
Oh, it wasn't its orbit a little closer? I mean, I was looking for its orbit track. It's like vertical, right? Almost.
Yeah, but we just have to get back. Okay, so let me center us up on this. No, I don't want to do that. I want to center us up on this. Why is it doing this? Why can't I just center it up on this? Why is
because you don't have a PhD.
Ventura, you're getting a little...
There it is. There it is.
You see it?
Shut up, Ventura.
You see it?
Right there. Yep, got it.
Not it.
Yeah, it is. Right there, 2MASS.
Okay. Right there. But look at what
hey,
happened.
Wait, you can see your cursor. Were you always able to do that on this?
Yeah, and this is display. Remember, I'm capturing the display, and I told to capture the cursor.
I thought last time you couldn't get your cursor to show.
When you're doing a capture the display with the two displays, you can do that. But when you're trying to get a capture card like Blackmagic, and you want to show stuff on the screen, and for those watching on my stream, this is exactly what we're going to do. This will be the Blackmagic screen. We're going to be looking at the sky, and I'll be able to point things out to you and show you things. I'm working on a graphic system to actually draw on the screen that you can see as well. So that's what's coming for SkyTour LiveStream.
Which reminds me, I want to talk to you off air sometime because I think I have an idea, if you have the programming knowledge, which I think you do, of the automatic detection and overlay moon map for streaming as well.
That would be pretty cool. Cause,
yeah, I have an idea because actually Astronomy
they do
Live
that. They do that now. They do that now.
A really good idea.
They do that now with the Earth and the ISS view. You can actually see what's below you and turn that on and off. It's pretty cool.
Well,
okay.
See, you know how we, like Paul always flips the camera?
Yes.
Like turns it in thing. Well, what this program would do, it would actually read the moon and what's viewable and actually have points, and it would compare all that data
Okay.
to where certain things are, and no matter which way reviewed, all I would have to do is hit a button, and it would literally put the correct crater name and Maria names and everything like that where they're supposed to be.
Yeah.
Even if he has the thing upside down, sideways, it doesn't matter because it's as I said, I'll talk to you later about it, but Astronomy Live gave a pretty good idea about it.
Okay, now this is the Earth. If you look over here in the upper right, and I'm rotating it, this is the Earth after this evolution of having a brown dwarf like 2MASS here come through our solar system. And right now, I mean, in all fairness, I mean, 2MASS has only come through about 40 or 50 times so far in this simulation. But in the real life, it would have come through thousands, maybe hundreds of thousands, millions, depending on when it was captured. So you can see our Earth is already a dead world, okay? It's a frozen wasteland. The temperature is minus 37 degrees Celsius. But let's keep going. Let's watch where that goes. All right. So you'll see the temperature gets all the way down to minus 40 Celsius. Okay, minus 38. And that's pretty much, I guess the minus 40 too, as it minus 40, minus 41. So it's changing dramatically. At minus 42, it's actually getting colder.
Do you think that that order will come of chaos with this doing this, or do you think eventually we're on board to have a collision no matter what?
Well, here's what happens. Originally, a solar system, when it's formed, there's some order in what we see. Okay, but eventually, when planets orbit in such a way that they interact with each other over long term, the orbits can do one of two things. They can stabilize, or they can be ejected. And stabilize is what our current solar system is. It's stable. These planets have stabilized their orbits. Look at Mars relative to the orbit of Venus. Mars is actually approaching, like 30 degrees on inclination, and it's all because this Nibiru stand-in keeps coming back down into our solar system and arcing through. All right, here it comes. Where is it again? I'm trying to find it again. But when it comes through, we don't actually have a real Nibiru in our midst, because if we did like this, well, we would actually see this thing and see the damage. We can actually work backwards. We can look at the state of our solar system now, and we can work backwards and see what it is or what it might have been, and that's something that we have never done. Something that the Nibiru crowd has never done. Had they done it with any kind of credentials, okay, and any kind of real analysis, they would actually understand why a Nibiru could not be out there.
Yeah.
Now
but they have a physicist.
Yeah, well, they claim they have a physicist, and I had a problem. That's the woman.
I don't know.
Yeah, I think they have a female.
You know what though? It's been like an hour and we still haven't blew anything up.
Oh, I know, but
I think we need to do that.
You said this. You said you wanted to see this.
I know, I did. I wanted to see this.
Yeah, but look what's going on here. I don't know if you caught that, but this little flora. See that flora?
I know. I seen, remember earlier when I said, what was that just flew across the screen?
Well,
this little white dot just went cruising.
That flora was one of the Florian asteroids, and what's interesting is it interacted.
They're all over the place.
Well,
they're flying all different directions.
Yes, I know, and that's the thing. It interacted with Earth earlier, and when it interacted with Earth, I watched it. It kind of went in and out of Earth's orbit. It was like spiraling around and starting to enter our realm of our gravity well. Look at these things. So here's
what Pacoca in the PNK chat. Yes, we're being completely sarcastic. Just so you know, just don't want anybody believing this. We're just trying to show you that what would happen if there really was a Nibiru. We would see it coming from years and years and years away, because it would start affecting our solar system majorly. And the way astronomers are, they would detect this movement.
And you got to understand that if it was here, it means it has been here and orbiting time and time and time again already.
Yes.
And the problem with that is, of course, that this that we're seeing now is approximately what would happen if we did have such an interaction in our solar system. If we did have such a mass doing this, we don't see this. Okay, we have stable orbits. In fact, we have resonances between the moons where they, they have a 1, 2, 4 resonance of Io, Europa, and Ganymede, and those stabilities wouldn't exist with a cosmic interloper that comes in every 30,000, 70,000, or whatever thousand years they make the claim for. They can't justify that with any science. Because look at the orbit of Mars. Look what happened to Mars.
I know. I was just about to say this. Man, look at Mars.
Mars is now an elliptical orbit. Mars was in a circular orbit just a little while ago, right? But repeated, this is the thing that's important, repeated visits by this guy. Repeated visits by this brown dwarf, this particular Nibiru thing. Repeated visits do this to our solar system, okay? So I'm sorry, if you want to try and pretend that there is such a thing, because you're alive now, you think that you have all the answers. Well, the universe has been here for 13.8 billion years, and the Earth has been here for 4.6 billion years.
And kinda, not completely, but kinda predictable what we see. And we can kind of, what you were saying, predict backwards.
We can work backwards, yeah. Yeah. In fact, working backwards is a lot of how science it's called reverse engineering. It has reverse engineered the solar system. But you know what? Here's what we're going to do. We're going to leave this because we know now that Nibiru is a farcical concept. And I'm sorry that's true.
We need to make a new planet again.
Oh, yeah, we're going to.
We need to crash Jupiter and Saturn together and make the lovely planet of Stupider.
Okay, how about this? Let's do this then. I'm going to take... turn
the Milky Way off.
Yeah, thank you. I'm actually going to... just... should we just start with a blank canvas and throw things?
Actually, I mean, if you can find... If this is just our normal solar system, and we don't have a blank canvas, like just our solar system without any comets or anything. Okay. I say we start with small planets, like, say, launch like a Mercury-sized planet into the center of the solar system. See what happens.
Really? From where?
From, like, just beyond Earth, maybe.
Maybe from here?
Yeah. Yeah, just to see what happens.
Okay, let's do that. So here we have a new solar system. And you'll notice, by the way, really nice circular orbits. See how predictable? See how beautiful? This is your solar system. Okay.
And this is your solar system on drugs.
That's our sun.
Any questions?
Right. This is your solar system on hydrogen. Yeah.
Oh, no, we got a helium freak.
I know what that's like.
So, okay, so let's do this. Now let's...
Hey, man, you got that helium?
We're going to slow this down.
Sure do.
There we go. And let's go to Earth, shall we?
Yeah.
Should we launch something from just beyond Earth?
Yes.
Okay.
Like a Mercury-sized planet.
Okay, let's follow Earth. Okay. So as we zoom into Earth, you'll see that the day is going very fast because we have it set to, 17 hours per second that we see. You'll also notice it's on a little bit of an angle. And by the way, based on where the sun is, you can tell what season it is already, for those of you that know. All right, this is near one of the equinoxes, equal night, equal day, because the halfway point is not near the lower part of the hemisphere or the upper part. The middle, it's right along the axis. So that's how you know it's an equinox. Anyway,
ladies and gentlemen, as much as we try, you're gonna learn something, whether you want to or not.
Well, that's what I said in my title. I said, we're gonna planetary destruction, and carefully you might learn something. So, and if anyone has questions about that, please go right ahead.
The rains down in Africa.
Yeah, and we're actually heading for winter right now in this because we're going this way around the sun, and as we go that way around the sun, the lower hemisphere is going to get more light because it's on an angle, see, and it's heading that way now. So it's going to get toward the summertime in the southern hemisphere, wintertime in the northern hemisphere. So anyway, that said, let's do some launches. And the way we're going to do that is we're going to add and we're going to launch a Mercury-sized planet at the Earth.
There you go.
But I do want to slow things down a little. And I gotta change the orbital launching speed, and that's one of the things I gotta figure out how to do. Auto launch velocity is on. I don't want that. Sets the launch velocity. We need to make a circular orbit. Give it a perfect launch. No, I don't want that. So I turned it off. So now I want to launch something. So how do I determine the launch velocity? By I turn that off.
You're gonna bash it.
Yeah. Well, let me just try and see what we get. So I'm gonna go like that. Was it here? Did it go somewhere? Where'd it go? Oh,
How
yeah.
do you, oh, and you killed everybody.
Just a little.
Just a little bit.
Well, that's the end of the stream, ladies and gentlemen. We
didn't even see that coming.
Yeah, I know, because look, I had it to like 17 hours per second. Clearly,
Sir, you have killed all of humanity that has ever been, or ever was, or ever will be.
Well,
Just by pressing a click of a mouse button.
Yeah, can you imagine if it was that easy? Okay, so all right, here we go. So let's go back to the oit. And go down here to the oit.
Yeah, would you have it at 17 miles a second or something like that?
No, it's just days, 17 hours per second.
Oh, Jesus. Yeah.
So I'm going to go down to, let's do 1 hour per second. And let's just see what happens, okay? And now we'll come back out.
You don't have to launch it at Earth. You can like launch it like kind of right by Earth.
Yeah, we
so
can
it just
see.
Skims us.
Yeah, well, we have to like predict.
See how long it takes to hit another planet.
Yeah, see, this is orbital. I want to launch. And I don't want to... There was a... See, what the other Universe Sandbox allowed you to set the launching speed, and I can't figure out where that is. Well, for now, I'll leave auto on. Let's see what we get. So here we go. I'll do this. Okay, it looks to me like
okay.
It went by.
Well, where's it going?
Oh, well,
where'd you launch it to?
I apparently launched it to there.
Alpha Centauri.
Yeah. So let's do it again. And this time we're going to launch it.
Better be careful. That little nugget's going to hit Uranus.
So here we go. We launch again. Actually, gonna
wait. Where's the sun?
The sun is this way.
There we go. We should launch it towards the sun, but past Earth.
Okay. Let's launch it like this. Okay, and this will be there. Okay,
there we go.
Slow it down.
Oh, it's moving. It's moving. It's moving. It's heading towards Mercury. We're all gonna die. Let's slowly. We've lost it. It's off the radar.
It's already off the radar.
it's gone.
All right. Well, let's just do this again. Until and right now everyone on Earth is going, no, please.
That little feisty Earth, don't make us launch Jupiter at you.
Ooh, yeah. Well, it's funny to watch Earth get, just absorbed by Jupiter, and Jupiter just goes on. Like, what was that? It's like, oh. Okay, 2 minutes per second. Let's see what this does.
There we go.
Okay, this is starting to look like
Oh my Lord! It went away again.
No, it didn't. It's there.
Oh, okay.
Yeah, let's actually do this, so we can see.
Okay.
I guess that's the launch direction, huh?
Yeah, and that nice 90-degree turn up the road there. Hope there's no deer in the road.
No, that's a gentle slope. It's just a graphic anomaly, as they say.
Okay. I like what you've done here.
Okay. Let's accelerate a little.
So, ladies and gentlemen, the new Mercury is slowly cruising towards Earth's orbit. Yeah. They will gently glide by one another, shake hands, as Mercury will move towards Sol, our big son. Oh, boy. Okay. It's getting a little weird. They're getting a little too friendly. We might... it might be like two cats that don't know each other. They might get in a fight. You have to get too close. Here, kitty. And can you imagine being on Earth right now watching this? Like, oh, look, there's Mercury, and it's coming right for us. And
it's heading right for us.
Oh, my Lord. Zoom in a little bit on it.
I am. It's well within this shape. Oh, man. This is definitely...
Oh, wow.
Definitely.
Oh, wow.
We're definitely...
Run, Earth! Run! Save yourself!
Run your butt off!
It's just gonna miss. Oh, man.
Let's just go slow and
Oh,
watch
it's
this.
gonna miss it. Maybe not. Yes, it is. No, it's not. Can it be? Maybe.
Maybe, but it's going to go
Yes.
into this
Yeah, we got it. We got it. We
highly
got it.
elliptical orbit, perhaps.
It's got to affect Mercury, them being that close. It's got to affect both of them in their orbits.
Well, yeah.
Well, wait a minute. How big is Mercury? Is it about?
Well, you can
It's
see
bigger
it's
than
like-
our sun. Or I mean, our moon, right? Or no? Maybe not.
Mercury's actually pretty reasonable size. You know, it's actually
They just missed. I don't know how you did that.
it's 4 times
but
the
they
mass.
literally came
It's not
forward.
over yet.
I know. Oh,
It's
I
not
know.
over yet, unless well, the projected path is that way. So I don't know how that.
Well, remember, we were doing this at one time, and all of a sudden, you know, the predicted path said, well, all of a sudden it started veering it off another way.
Yeah.
See, look, it's bending. It's going to the right. Just a tad
What is?
more. Or Mercury. New Mercury.
Oh, look, there's another Mercury.
Old Mercury. Wait, which one is the one you launched?
That's the one I launched.
That one is.
Yeah, but this is
So,
one. This is one.
Old
that's-
Mercury is.
What the heck?
Old,
Look at this.
Wait, what? What? Did you launch more than one, maybe? By accident?
I guess I did. Look at that.
Oh my god, 2 Mercuries. I knew it. Shut up, Ventura.
Well, you know
That
what?
is- okay.
We're gonna
okay.
actually. We need to launch another
We
Mercury.
have we have 3 Mercuries. I mean,
We have another
why not?
Mercury to launch. Okay.
Launch a Venus.
No, I'm gonna launch another Mercury. You ready?
Okay. Yep.
Okay. There we go.
Oh
Now
boy.
let's.
Here we go.
Yeah.
Here we
let's,
go.
Let's see what happens now.
Enjoying a nice picnic with the family, laying in the grass. And now there's 4 Mercuries.
Daddy, what's that in the sky?
That's
Oh.
our death, son.
Well, Bobby, it looks like the moon. It's getting bigger. No, Bobby.
Oh, here it comes.
You just need to learn about science. Science.
Now you're tracking Earth right now, right?
Yes, I am.
Which is why it's stable. Okay. So this is oh my lord.
Mm,
And nope.
It's a miss.
It's cruising pretty good, but Earth's not going to catch it.
Yeah, but that's pretty good, though.
Okay, so now we have what, 4 Mercuries?
Yeah, we certainly do.
Okay, so we have 4 Mercuries now. Now, actually, back out and see where all the Mercuries are going. Like, are they? Maybe they'll end up colliding. Oh wow. Okay. Well, sure. Wait, you have them on a straight trajectory. don't you? Well, they may. Oh wow. Okay, our 1 Mercury's a little slow.
Yeah, they're
But-
actually. I want to do this. I want to actually. I do want to launch another Mercury, but I want it to be like at the Earth.
Okay. And is it going to do it? Is it going to do it? Is it going to do it?
Let's go down
To the 50, the 40, the 35, the 30. He trips and falls.
Where is it?
And we lost it.
No, he didn't.
I don't see it anywhere. Do you? You watch,
It's-
it'll appear 10 minutes from now and just
There
come
it
flying
is.
and kill everybody. Okay, it's above the plane. Okay. There we go. I don't know. It's well, it might do it.
I don't know why. It's like it's almost like gravity's not being affecting it or anything, but it's got to be. Uh-oh.
Oh my lord.
Oh, a grazing
Oh,
impact.
Oh, just Nana, but Mercury survives.
Well, it survives as a
And it's-
smaller planet, and look at Earth. Holy cripes! Now,
Oh wow. We all just died.
well, let's see who lived. Let's go on the other side of the planet and see what's going
Nobody
on.
by the time that fireball gets around there.
Yeah, and our orbit's just been
Extinct.
totally changed, and look at that.
Dude, look at the land masses. Look at
Yeah.
how much land's forming. Oceans are gone. Dried up. Take care now. Bye-bye then. More water. We're all
Oh,
done.
there we go. Look at that.
Oh, Jesus.
Yeah, you can see.
All the humanity.
Oh, the humanity. Yeah, look at that. It's actually superheating now.
That was a glancing blow.
That was
wasn't
a
even
glancing
straight.
shot, too.
And Mercury number 5 survived.
Well, it's much less mass, probably.
It is, but it looked like it was gaining the. It looked like the.
It might have accreted some of the stuff that it got off the Earth.
Like the offshoots looked like it
Oh,
was
wait,
heading.
what's going on here?
Exactly. See, that's what I'm talking about.
let's go see what's going on.
Okay, who's smoking?
And that is, let's see its mass in terms of, well, look at that. Actually, you know what that's doing? That's kind of cool. It's telling you where the sun is, actually. Because the sun is got radiation, pressure, wind, solar wind, and it's blowing. It's actually causing some of the material that's going into the exosphere around Mercury, that is the area around Mercury,
turned
to go
it into a
shooting out.
comet.
Well, that's just the solar wind causing this interaction with the hot particles that are coming off of this thing.
Are you telling me Mercury has gas?
Yes, I'm telling you that. And it's just it's the hot material that came off.
Nice.
Yeah, and actually, something else right there. That's a fragment. See that little fragment?
Yeah.
That's one of the fragments that came off in the collision. That's amazing.
That was a pretty fast hit too.
Yeah, that was actually
scorching in there.
Yeah, let's see what Earth's looking like now. Oh yeah, well there you go. See, now we know that the Earth could never handle that kind of an impact. Cause look at that. Now over time, here's what we should watch. Watch this now. Over time, if we speed this up, hopefully we can get this going far enough here. You'll see that
it's cooling.
It'll cool. Yeah, it's cooling down. You'll see that we have cooling taking place. See that?
Even though all our water is gone.
Look on the upper right there. Okay. See how it's cooling? See that? Well, you say the water's gone, but the problem, the thing is, the water was vaporized, but we do have gravity, and it went up into the atmosphere, and it's going to come back down again. And it's going to rain.
It's going to take a long time.
Yes, it will. It'll take many,
especially
many,
being purified, to be able to use.
Well,
like for human consumption anyway.
Well, there's no humans to worry about, so.
Because you killed them all, you murderer.
Yeah, but you can see now, the program doesn't simulate the fact that the human race is now dead, so it still thinks there's lights in the, after the planet cools. Okay, we got lights again. Not at all. You're just seeing the
electric's back on.
Yeah, ooh, that looks like a skull.
Internet next. I know, right?
That looks like a skull right there, or
somebody going skull with a top hat on.
Yeah, or now look at there's a Wandjina. Only one person will know what that is.
Let's throw Earth into Jupiter.
Okay, let's do that. First, we'll do. Let's open up just the Jupiter system, so we don't have to worry about all the stuff.
So let's throw Earth into Jupiter, and then after that, let's throw Jupiter into the Sun.
Oh, okay. So now we see that Earth would not survive. Now here is Jupiter with all its moons, okay, and even more orbits. So we can actually turn all that off, and these are the tracks, okay. But
remember we did something like this one time and the moons just went nuts. Like we'd lost one of the moons and just started heading out into interstellar space.
I know it. It
was crazy. But it was a big impact.
What do you want to do now? What do you want to throw? Earth?
Let's throw Earth at it. Because the Earth is roughly the size of the spot, right? So
yeah. So let's
see what kind of impact that makes on Jupiter.
First, I want to put Earth in orbit around Jupiter.
Okay.
Okay. I'll put Earth in orbit around Jupiter, okay. And now we'll just want to watch what happens. So
Uranus is bad, guy.
Turn on the trails and watch what happens to some of these moons. Now Jupiter's got massive gravity. Okay, we're actually within Io's orbit. There's Io. Okay, so we actually probably should have put that a little further out. So let's actually do that. Goodbye. All right. So now. We've only made some minor changes to Jupiter's orbits, but let's actually put in Earth. Let's put Earth out, like right here. Let's put it out near Europa. All right, so now we have Earth. Ta-da!
And look at the moon's orbits right now as you speak.
Yes.
Now watch what happens when he speeds it up.
Yep.
Crazy. I mean, Mattis is already kind of coming out of its...
Okay, now see, Europa goes a little faster than the Earth because it's closer, but watch this. Okay, so now Europa is going to start getting tugged by the Earth.
Callisto's out there like, wait up for me, guys. Come on, guys. Don't leave me behind. Wait up.
Yeah, see this? See how this works? See how it's getting narrower?
Mm-hmm.
Look at this. Uh-oh.
Oh, dead.
That
Didn't
was
expect
bad.
that fast.
Well, I should have slowed it down. But you saw that was a deadly collision. Let's do that again.
There wasn't even any fragments or anything from that. It was just Earth swallowed it. Like, took the brunt and just kept it.
Does that look like it swallowed it? I mean,
Well, I mean, it absorbed the impact. There was no fragment or nothing.
Yeah, that's for sure. So let's do this again. Now, what do I want to do here? I want to show.
Let's hit Earth.
By the way,
spot.
this is the orbits of all Jupiter and its moons, okay?
Yeah, looks like a yarn ball.
Yeah, a yarn ball. How about that, huh? That yarn ball has so many moons. That's crazy.
When you talk about the cosmos, you're talking about a needle
when we talk
in
about
a cosmic
cosmos.
haystack.
Yes. If you have 10,000 matches and your opponent has 5 matches and you're both in a room full of gasoline, who has the advantage militarily? That was a Carl Sagan analogy that he actually stated. Ventura, shut up. So now we're in here. We're in the central area again. And now, should we just launch?
Do it.
Yeah, I'm just going to launch. What the heck? We're not going to
launch Earth right at it.
We're going to launch Earth right at it. And we're going to go... let's start off at 17 seconds per second. Just make it nice and slow. Okay. And now we're going to launch. Let's see what we get. We're going to launch, say, this way. Okay. The opposite direction of the orbits.
Okay.
Boom. So now.
Look at the pretty planet.
Yes. And now we're launching. We're going to get a little more speed here. Yeah.
CPF. It's just in case we let cursing slip or anything. I just did it on a P&K stream where it's not 18 plus on Mark stream. It's just
I'll get in trouble. Keith won't.
Ha!
I'm telling you, if I get banned for 90 more days, you are never going to hear the end of this. Okay.
You'll just be streaming on P&K. That's all.
Yeah, I know, right? So here we go.
Let's do it.
All right, here we go. We're going to speed up now.
Here it comes.
Yeah, I got to just see. We got a ways to go here, so everybody on Earth go, no! All right, here we are. So we're in here now. Let's slow her down.
Slowing her down.
That's too much.
Yeah, it almost seems like never the right amount with this.
I know.
Like, too fast or too slow. Oh, we need a Goldilocks button.
Look, Ma, there's Ganymede. Okay, so now Earth is literally heading this way. Let's see what happens, though.
Dun, dun. Dun, 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 dun.
Yeah, look at the curve.
Jupiter, and it's curving.
The biggest.
And it's going in.
Oh boy, look out. Okay, so let's do this.
And he called it. Into 30, 35, 40, 45,
we're gonna
50.
Drop this down.
45, 40, 35.
Here in the last days of Earth.
Let's get ready to rumble. Oh, this is going to be a skirting shot.
No, it's not.
You don't think so? You think at the last second it's going to pull it in real sharp?
I know what's going to happen. You're going to watch this thing do... There's a couple things it does that are really weird. Okay? Now,
it's going to start pulling the planet apart, if anything.
Well, it should, and we do have a Roche lobe simulation within the simulator that looks really good. I slowed it down now to 21 seconds per second because you can start to see the shadow of the Earth now in the upper clouds. And for those who watch the Jupiter stream, it's going to impact in one of the zones.
Oh, here we go.
Here we go.
And take care now. Bye-bye then.
Yes. See? Told you.
Now watch. Wow. Look at that. Now that's something.
Yeah, and now we got lots of fragments.
Lots of fragments. We're going to totally screw the zones and bands on.
Well, it's actually going to make a large scar. Okay, see the scar? And you've got all these fragments. Now let's accelerate it a little bit. You'll see the fragments are going to start coming back down, and they do. You can see them now hitting elsewhere. Okay. This
So
is,
it's just hitting it and broken apart. Now they're coming in and hitting it.
and they're not going out too far because, of course, the problem we have is that the object is much smaller mass than Jupiter. So therefore,
Oh wow! Look,
oh yeah, I know, and so therefore you can see expanding shock waves. See that?
there are some big fragments too.
Yeah. So the fragments aren't going out into space because Jupiter's gravity is pulling them in much quicker. So we don't even get a chance to do that. We don't. What the heck? Okay, there's a little strange thing going on out there.
Fragment.
Yeah, I'm not sure what that is. That looks to me like a mistake. Yeah, but look at the scar.
We created firework.
Yeah, so you can see that there's
Now,
some
you
graphic
tell me
issues.
so that won't get caught up in the clouds and whatnot.
Oh no, that's the whole point. This does.
We just went totally pixelated.
You did?
There we go. Yeah, it's coming back.
Okay,
I
gotta let it.
There we go. It's coming back. Just the names are all like all the fragment names, but you can't really see the fragments. But
you can't. Look at this though. Let me see if I can zoom in on this. Okay. You can see how this is can you see this expanding shock wave in the stream?
Yep.
I don't know if you can, but that's actually
Jupiter's so big it's hard to see, but it is expanding slowly.
Yeah. That is really something. And you can see that, when stuff happens in the upper cloud bands, okay. Remember, this is 30 seconds per second. Okay, if we accelerate this, all right, then we can get to
do it.
Yeah, I did it already. So we got about 5 minutes per second. And you can see the shock wave now has traveled out. Can you see that?
Look at it destroying. Oh, it's heading towards the storm. Let's see what it does to the storm. The shock wave.
Yeah.
Oh, sweet. Oh, it's going to go in the dark.
Well, the shock wave is still going to be visible.
Oh, bugger.
The shock wave is self-illuminated because of it's like a plasma in the upper atmosphere at this point.
Well, at least we know we only have to go about 9 hours to see it.
Yeah.
Comes back around.
Yep.
And still, there's just a little fire burning over on that side.
Yeah, but there shouldn't be, actually.
Yeah.
That's a mistake. And this is a graphic anomaly. That's because we accelerated it. Okay, that's what happens. See, all these other things, these are all graphic anomalies. It shouldn't be there. It's a mistake. I'm zooming in, zooming out, then changing things. The accuracy gets compromised. So that's like a
because once again, this simulator, it's not really a game, it's a simulator that actually is doing all these physics as we're doing it. So
yeah, it is doing
it does
millions
take
of
a lot
physics
RAM.
calculations. Yep, it is. And now here comes the
Okay, here it comes.
Here comes the shock wave.
Oh, so it passed the spot.
No.
Or
the spot is just
is no longer there.
Oh yeah, you're right. There it is.
Wow.
Yeah. So we look out. This is what we'd see from the Earth. Okay, we would see like Jupiter, and we'd see this dark area, coming around. That would be wild.
Yeah, I know, right?
Scary.
All right.
Cool.
That was cool. Now let's launch Saturn into the sun.
Saturn into the sun?
Saturn into the sun.
Oh, well, all right. Actually,
let's launch 5 Saturns into the sun.
We're going to have to, okay?
Yeah, just to see them.
Let's do this. We're going to set up a new one. And I'm going to add a sun. All right? And I'll add our sun right here. Boink. All right. And then we'll add stars to stars, and you can watch what happens there. That's pretty fun.
Oh, yeah. Let's do that.
Yes.
Let's collide stars.
Oh, yeah. It looks phenomenal. Okay. And let's get the background down to just stars. And, okay, so now, here we are. We have the sun. All right. And from a distance, it's this little tiny point of light. But up close, it's a big cauldron of hydrogen fusion going on. You can actually see the motion on the surface there. Okay, this is accelerated time too. This is 1.3 hours per second. So this is about how those these are called granules. Granules, Granules, granules. and they're like
we were seeing them today during the moon stream.
I bet you were, and during the moon stream, that's amazing, considering you're on the sun. But I know you meant the solar stream.
Solar stream.
Yes. So these granules are like little, the outer envelope of the sun. These are little convective layers that you see, and they pop up, and the hotter gas is in the middle, and it's the whiter gas that you see there, and then the rings around each granule is the cooler gas going back down in.
It's like a big swimming pool of death.
That's right. That's right. In fact, all we have to do is get about a million miles closer to the sun, and it'll be a swimming pool of death for us. See, the sun is not the best star to have for planetary life giver. I mean, we could actually have a better star that didn't hurl ultraviolet light at us all the time and cause skin cancer and stuff. There's a whole bunch of things. But that said, let's dispense with the science and let's fling something at it.
Let's do it.
Okay.
Another star.
You want another star? I thought you wanted to do
Yep.
Saturn.
I'm almost interested in another star now.
Oh, I know, but I'm going to throw Saturn at it right now.
All right.
You know why? Because I
Go
want
for
to. So
Go for
let's
it.
do, we're going to drop this down to 13 minutes per second, see if it makes a difference.
As we watch the destruction from the galactic plane.
All right, so now we got enough. And I did not add the rings to Saturn. All right, but I just want to do this so you can see what's going to happen. All right, let's actually focus on the
look
sun.
at that. Saturn's already starting to act funny.
Is it? Oh, it's definitely... Oh, Saturn's definitely going to be a bad boy. Boy, it's going to...
Is it just me, or is it going egg-shaped?
No,
Or is that just my...
it's your expectation.
I wasn't expecting it, truthfully, but... I think it's because the line kind of messed with the optics of it.
Yeah, it
just
might
made
have.
look like it was a little...
However,
egg-shaped.
if you do put like a moon too close to the Earth, you'll see that the moon does get destroyed.
Mhm.
And that's because of the fact that it's within what's called the Roche limit, and the differential gravitational tug on the planet will just by the.
Hello, Heidi, and welcome. We're throwing Saturn into the sun.
Here we go. Oh, it's going in. It's going. It's done.
It's going...
Goodbye, Saturn. It was nice to know you.
Oh...
Now, and we're here at 30 seconds per second.
I'm surprised it...
Whoa.
Oh.
Okay, that was a glitchy thing to happen.
Baby,
at
turn your
that.
brown eye blue.
Look at this.
Wow.
Oh, I get it. The universe died.
We broke space and time.
We broke space. Okay, I have no idea why that happened. And we're going to start over with a new one. And I'll just, instead of getting rid of the background, I'm just going to move over here. So now let's add the sun in here again. Okay, now let's do this. Let's take another sun. And let's, well, we can actually see what will happen. Let's orbit one around the other, shall we?
That's gonna be good.
Yes.
Oh, wow.
Right. Ooh.
Oh, my Lord.
Yeah.
I look closer than it was.
Yeah, it's definitely they definitely have some motion with each other. The sun comes in with motion that it has normally, but whoa. Whoa. Yes.
So how far away? So they are maintaining their... Oh, no, look at that. Okay.
No, that corkscrew's normal because this is moving and we're following it.
Right.
Right. Okay. So you can see that it gets really close.
And then it whips around.
And it whips around, right? It's an elliptical orbit. That's pretty good. So now if we just watch this for a period of time, let's see.
We should put a planet between the two.
Oh, I don't know
Like,
if we...
like a big planet, like a Jupiter. Just put it in between.
Well,
Can't we
don't
find
have,
a way to...
We don't have enough room when it gets close. I could delete this and make these
No, can't you just stick like a stationary Jupiter, and like kind of when it's out at this further point, stick Jupiter like in between it, so that it doesn't orbit or anything? Or can't you do that?
Well, you get.
I just want to see if the gravity would rip it apart.
Well, you can't. You can't. Well, Jupiter's gas.
Exactly.
You can't. You cannot turn off physics on one object only, as far as I know. Maybe you can. But so this is a binary sun. This is two suns going around each other. But let's do one thing. I'm gonna get rid of this guy. Goodbye. All right, and now let's put another one in. But this time we're gonna put the orbit a little bit more reasonable. Okay. Let's see here. It's like this. Okay. And now let's put in something orbiting one of these stars. All right?
Or both of them.
Yeah, or both. Can you imagine that? Kapling.
Like each one has a planet, like a giant planet orbiting it.
Yes.
That'd be cool.
Okay, so let's do this. Let's put a Neptune around. Let's see how close it gets. Okay. All right, so we're gonna have to put it really close. Let's see if we can do a Neptune this close, and then around this guy, let's put a Jupiter this close. All right, so now.
Oh my!
Oh yeah, they're gonna be incandescent before long. Yeah, because of the proximity, and they're gonna evaporate over time. Actually, you'll probably be able to see the evaporation. That's pretty interesting. Okay, you'll see that Neptune will start to lose material, and that's
hot tamale.
That's called mass loss. Okay, and there's mass loss that will occur on planets that are too close to a star. And let's see, like, okay, now look. This is something.
I see it. It's Jupiter's just had enough.
No, but see, this is what I want you to see. This is important. Now you see what's going on. Okay, you see all the little bits? These little bits, okay, are what's left of Jupiter. This is kind of cool because this kind of gives you an idea, like with Comet Shoemaker-Levy, as it approached Jupiter. It got broken into a string of pearls, and that's what happened here to Jupiter. Okay, so as we look at Jupiter, it's being incinerated and pulled apart.
Did that just happen because Jupiter's a gas planet, or
no? Because I'm gonna put another one in orbit around it very soon. Neptune already was.
Put a giant rocky planet around.
I'm going to Neptune,
and then put another sun orbiting the two suns. Way out. How cool would that be? A triple star system.
That'd be pretty interesting. Okay, let's do this. What's this one? This one's 6 times the mass of the Earth. That's a gas giant, though. Let's just do a big terrestrial planet. Let's take an Earth, all right, and put an Earth right there. Okay.
Mm-hmm.
And now let's get that Earth. Earth is already incandescent and lifeless. Okay. Oh yeah, the surface temperature is 1,725 degrees Celsius. Ooh ah.
Lovely.
That's beautiful. Beautiful. Okay. But you'll get to see what happens with this, and let's focus on.
Oh wow, it ain't gonna hang around long, is it?
No, but I think what's interesting is you can actually see the trail behind it. See that?
Mm-hmm.
It's already being vaporized. Yes, sirree. Already being vaporized and leaving.
Neptune was like later. I'm out.
Oh, yeah, it was gone a while ago. So here comes Earth. Okay, you can see now that Earth is leaving a trail of vaporized particles.
A trail of tears.
Yeah, actually, and what's interesting is the interaction between the two stars looks like it's ejecting Earth from the star system.
Yep.
Let's go and see if that really is true. It's true. Earth got ejected. Wow.
And it's probably in the habitable zone right now.
Oh, actually, look. The temperature on the surface is dropping. It's now 70 Celsius, 60, 50. It's probably going to get down. Look what's going on over here, though. This is kind of crazy. Why is the star spinning like that? There's got to be something else going on.
Is that the one with Jupiter around it?
Might be.
Or...
Might be. Let's go see. Let's go see. Oh, look at that.
Yeah.
Yeah. So Jupiter then, on this one, is kind of interesting because it created this well, it created this mass, basically this plasmatic mass of you know, how many Jupiters? It's got to be less. Yeah. See, it's being vaporized. So this is the mass of Jupiter here. 0.0000000000009. Okay. And as far as mass of the Earth, it's just a fraction of the Earth even now. And this was Jupiter, man. That's crazy.
I wonder what would happen if you made a solar system out of suns. You know what I mean?
Yeah.
Like put like a big one in the center, and then put one like a little ways out, and then another one, like, and just have them all like orbit and see what happens. Like do like 5 suns.
Okay, let's do that.
With like one big one in the middle, and then just do different suns like further out.
Okay.
Since
I like.
Let's see what happens.
Sure.
Watch it like you'll hit go, because you don't want to start them like you definitely don't want to have it be going as you're placing the suns. So you want to pause.
Let's put. All right, let's do it at a relatively large star, though.
Yeah, like a Canis. Yep, perfect.
Oh, you want to do VY Canis Majoris?
Yeah, sure. We'll put that in the middle. That's the big guy. That's the anchor.
Oh, that was the former. That was a star that used to be the largest star in the universe until UY Scuti came along. UY Scuti 7.94 astronomical units in radius.
Either one. Which one you want to do.
All right, we'll do UY Scuti.
Okay.
No, we'll do Canis Majoris. This is VY Canis Majoris. Okay, now you'll notice that the granules on the surface of this star look different, and that's because it's this massive hypergiant star. So everything happens with these stars on a large scale, including these granules, these areas here of the atmosphere of the star. It's this star's atmosphere, or the envelope around the core, is fully convective, I think. So that means that there's these long, deep convective cells, and they dredge up material from deep inside and bring it out. All right. So let's just say now, let's put should we put a sun?
Yeah.
Let's put a sun planet here.
Put it in a good way out, so it's not like affected, like it's not real close, but like just enough.
Okay.
You know, we'll just build a. There we go. Yep.
And that's going to be.
And that's going to be our size sun.
Yeah. And it's going to be 100 AU.
Okay.
Away, or so. Now let's put in Arcturus, which is a giant. Its radius is quite a bit larger than our sun, I think. And let's put that in a little farther out, shall we?
Yeah, a little bit more. A little.
Oh, sorry.
Oh, that's okay. That's cool.
Okay. And now...
Yeah, there's 3.
That's 3.
Let's do a big blue. Let's do Rigel.
Yeah. Let's do Rigel, yeah. Okay.
Is that how you're supposed to say that, Rigel?
Yeah.
I've always been saying Rigel for some reason.
Yeah, no, it's Rigel.
Okay, Rigel. Rigel it is.
All right, and...
Rigel it is.
I don't know why it's not letting me...
It won't let you go any further, like in an orbit?
No, it should. I don't know why. Maybe it is. Let's see if
maybe the game's like, look at these assholes.
Let's just accelerate this. We can go up to a few months, 1.45 years per second. Again, stars move slow.
Oh, here we go. Wow. Oh, my Lord. What just happened? Dude.
Ooh, look at that.
Look at that thing.
Wow, we got a really colorful interaction there. So what we found
There's no way the sun is leaving.
Well, here's
and Arcturus. I mean, literally,
here-
there was that much to
yeah,
inject both of those.
here's the problem. Okay, Rigel is much more massive, so Rigel became the dominant planet, so to speak, the dominant star in the system, and VY and Rigel are closer matched to each other, although they're not matched to each other. Okay, if you look at VY, all right, it has a mass, I mean, a radius of, diameter of literally 13.2 astronomical units. Okay,
Jesus.
that's a big
Okay.
freaking star.
Well, here's the thing. Let's do like 3 or 4 Rigels, or 3 or 4 of the same sun.
All right, well,
See what happens.
now let's just show Rigel here. Rigel, okay, is 21 suns, in mass. Okay, VY is 170. All right, compared to 1 sun. Okay, so I'm thinking that we probably want to try something a little different. So let's do what you suggest, maybe.
Yeah, let's just take like 4 or 5 of the same sun.
Okay.
Same, gravity,
Yeah.
same mass.
Well,
That way we can
if we don't have
see
a
what it
massive
does.
thing in the center, then they're going to do barycentric orbiting, and that's going to throw them all off. But that's okay. Let's try it. We'll just do it. All right, let's take a nice star like... Let's take Proxima Centauri. Proxima is a really small star. Okay. And let's now back away. And let's add a distance. Let's add one right here. And then add from here. Let's add another one. No, don't do that. Another one here. Once you get to beyond 3 stars, the stable system is no more. I mean, it's very difficult to get a stable system.
Well, let's speed her up and see what happens.
Alrighty.
With just the 3 of them.
All right, let's do that. So we have these 3 Proxima Centauris. 2 of them look like they might settle into some type of orbit, but it appears that they're kind of orbiting each other. But the fact is, they're actually doing this this little dance.
This mating dance.
This is right. Yeah. Okay.
Hey, you look like a Proxima Centauri like me.
You're like me, yeah. Hi, Miss. You Miss Proxima, 2499. Yeah.
And our other guy's just kind of cruising out there.
Let's see what happens.
Yep, let's find out.
Remember now, we put him in orbit initially, but the interaction between these 2 could throw off that orbit.
Mhm.
Although he's still curving, see, and that's something to consider. So he might be so far out that he's now orbiting both of these. You notice their orbits are getting more elliptical, though.
And his curve is not exactly, the guy out there is not exactly a standard curve. Like, notice how once the sun comes out towards it, it kind of pushes it out a little bit. And then when it goes away, it kind of comes back in.
Well, we're actually following one of those inner suns, so it looks like it's doing that. It's not. That's an illusion.
I'm looking at the line.
You know what the line? See, the line
It's
is
kind of just
the
dips
line is
and-
following the same path. But see the stars all moving in the background because the whole system's moving because we're following this guy. See, we're following this guy. And because we're following this guy, you'll see that as he comes closer, it'll move this closer star against the background. It is an illusion.
An illusion.
It is merely an illusion. I don't think Mars will attack us.
It's kind of neat, though.
Yeah. It's like you want to play like the Blue Danube.
Can you imagine the amount of radiation in that area?
Well, these stars, the M stars, actually do throw off a lot of ultraviolet radiation. So that's why, even though most stars are M stars in our galaxy, we can't expect that they will harbor, massive amounts of life. They will have some for sure. And the early M stars might be a little bit too energetic, perhaps, or maybe late in their life they might be energetic. So we need a nice stable star, but M stars last trillions of years, not billions like our sun.
We should put like
Look at this go.
Saturn and its rings between the two stars and the outer star, like have it orbiting. I'm not sure how that. Oh wait, here they come.
Speeding it up, yeah.
Uh-oh.
Yeah, I'm speeding it up.
Uh-oh, the other one's making a turn.
That's coming. Right. Something's going on.
Here it comes.
Let's slow it all down, see what happens. What do we miss? All right, here we go. So let's see what happens here now.
Oh, this is going to get freaky.
Yeah, maybe. Or it looks like it's still just orbiting.
That's crazy after the turn it made.
I know.
So those two are pulling pretty good. There we go. There we go. Oh, here we go.
Yeah.
Oh, wait, he got close, and here he comes around. He's coming back.
I think they're actually stable. Yeah.
I think so.
Yeah. No, the problem is that by going fast, we're causing the physics to get less accurate. So we could actually cause them to collide without wanting to. But we could do one other thing too. Let's go take an orange giant like Alphard and throw it into the system. Shall we?
There you go.
Oh, now what's going to happen? Oh, I don't know. Here comes Alphard to spoil our
put
fun.
A big sun in our solar system.
It's going to spoil our fun.
Oh, yeah, they're heading towards it.
Yeah, but think about this. What happens when stars collide? Does anybody really know? Yes, we do.
New magical space dust.
We know what happens when stars collide. And you watch.
Here we
Boom.
Kaboom.
Yes, we have an expanding supernova.
Yes, we are in a supernova remnant now. And then we have the one remaining Proxima that was left behind. You know, all the rest are supernova remnants. Pretty cool.
Crazy.
Yeah.
Back far out of that?
Okay.
Just to see
where it ends.
Look at that.
Yeah.
And that was all three of them, or that was?
No, there was two of them, and one left was on the outside. Supernova might not destroy the original. I'm sorry, all the planets in the system. And the simulator allows you to look at any one of these fragments and mess with it, which is kind of cool.
Let's speed it up if you can.
Well, I can, and what happens is it speeds up until it disperses into the interstellar medium. But let's do it.
Oh, it doesn't like form a planet or nothing like that.
No, it won't. It won't do that. Okay. But see, the gas is moving independently. It's not just zooming in on the same generic cloud. The cloud does change over time. See how these filaments are changing?
Yep.
It's following the physics as expected. Now, we got to back out again. And now this will be several light years across by the time it ends up dissipating or the energy is lessened such that it will then go into a it'll go into a quiescent state and end up losing energy to the interstellar medium, and then the gas will no longer be glowing, and it will become dark gas that gets mixed into the interstellar medium, which then could make planets sometime later.
That's where element 115 comes from.
That's not true. But you know what you could do, and this is something that we won't do now, but see all these little supernova, all these things? You can click these and pick one, and if you send in an asteroid, you can then send these supernova remnants into the asteroid, and what they'll do is you can actually build a new star out of the asteroid because it'll acquire mass, and the terrestrial mass, the rocky mass that's in the center, will end up being obliterated by the newly found gas that comes down on top of it and heats it up, melts the rocks for a while, then vaporizes the rock, and then finally you just have gas in the center. And the star will be made with the elements that were in the asteroid originally, plus new elements here in the supernova that was made. So that'd be pretty cool. Yeah. But let's get out of that. We're done with this. Let's say new. And what do you want to do now?
Stupider.
Okay. Then to do that, we need to add Jupiter to the mix. So there's Jupiter. Ta-da.
Saturn plus Jupiter equals stupider. And the rings. Don't forget the rings. We want to have fun with those too.
Yeah, I know. And I'm trying to remember if I can do it this way. Or, well, let's try it. Let's see Saturn. Let's do this. So there's Saturn. Sega Saturn. Okay, and now what I want to do is, if I go here, under actions, can I add moons to the planet? I can add the moons. You know, see if I can get those. And that's cool because then these moons are going to go and you know,
start disappearing into Jupiter.
And they do. And you notice you don't even see the energy because it's just, you know. Yeah. So that's true. And where's Titan? There it is. Oh, look at Titan. Titan's now way out there.
It's a ripping.
Yeah. So yeah. So let's see. Oh, now we got impact. See? Impact.
Yep.
Whoa, somebody's curling around there. Oh, that's just the regular corkscrew. So yeah, this is neat. Very cool.
Smash them.
Very cool. Ha 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 ha.
Smash them together.
Okay. Let's take Mercury though. I want to take Mercury and I want to throw it into Saturn. Are you ready?
Do it.
We're seeing a shadow. The deadly shadow.
I'll tell you what, this game got the physics on lock.
It does.
I bet you if you had a pretty good, like, a massive RAM, it would be crazy.
I do, actually. This is the game can easily outstrip, you know, because it's so incredible. Now, let's just go a little faster, don't you think?
A little bit.
Okay, here we go. Oh, was that not me? Oh, yeah, that was. No. Yeah, okay. I thought that wasn't my shadow.
Oh.
This apparently is my shadow. No, it's not. Uh-oh. I think this is going to be bad.
Gonna be dirty.
Oh, my.
There it was. Hey, look at that. Mercury made Ronstown. Nice little square stamp.
Yeah, that's artifact. Yeah, that's pretty neat. Look at this. Atlas does this little corkscrew thing. But, you know what?
Are they getting closer, or is it just me?
No, Atlas is going to collide with Saturn.
No, it's about Saturn and Jupiter.
Oh, I think it's just you.
Yeah, perspective.
Oh, Atlas is not going to collide. Atlas got away. Okay, so now let's go and let's throw Venus at Jupiter. What do you say?
Do it.
Okay. In fact, let's throw several.
Holy crap.
I know, huh? And they're going to be... Oh, I threw more than that. I did bad. I done a bad thing. Yeah, and Venus is going like, oh, hey, look at, see, look.
Hey guys, wait up. Okay, let's see. Does that energy impact Saturn? Yep.
Yeah, it did. Okay.
Saturn's getting swallowed out there, getting heated up pretty good.
Yep.
Now, is Jupiter any more?
The game. Well, Jupiter will remain cohesive because it's a mass center, so it'll be something. And the game doesn't change the cloud bands. You know, once it cools, it goes back to being what it was, which is not realistic. But you can see how Jupiter's gravity brings these fragments in again, and the fragments will now collide with Jupiter in a variety of ways, a variety of places. Okay, and they will impact, and they will cause this amazing, you know, like those impacts, you know. And now this whole area is incandescent. And again, I think these things out here are just artifacts. They're not supposed to be there. I've actually written them and told them, hey, you got some strange artifacts here. And we'll see what happens. Yeah, look at that. So let's accelerate and see what this does for a minute. Yes, sirree.
Sucking them in.
Yep.
Like a vacuum.
Well, see, that's why you're actually watching Jupiter in action. This is what Jupiter did in the early solar system. It actually kept us from getting nailed by these large.
Dione out there doesn't know what to do.
Oh yeah, Dione knows what's going to happen to it though. It's actually going to head off, and Dione and Tethys are going to be disappearing.
Now, isn't that crazy? Jupiter took the impact, yet Saturn remains the hotter one.
Well, that's probably relative to the fact that, you know, maybe Jupiter dissipates its energy easier.
Oh, I thought that was going to.
I thought it was going to hit, but you know, again, without having 3D stuff in the way, you don't see the 3D, you know. Okay, so we've destroyed that enough. Let's get out of that. What do you want to do next? Let's see. Okay, hey, how about this? Let's do something cool. Let's take Earth. All right, and we'll put Earth here. All right, and now I'm gonna orbit Mercury.
A little blue marble.
I'm gonna have Mercury orbiting it, but I'm gonna do it in a really strange way. I'm gonna have Mercury too close. Okay.
Mm-hmm.
And I want you to watch what happens. Let's slow down a little. Okay, so come on, let's get us back on Earth. Let's get center up. There we go. So now, we see an eclipse right there. It was an eclipse coming in. I think I gotta accelerate a little. Let's accelerate. Oh, I missed.
Wobble, 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 wobble.
Yeah. I don't know if it's doing it. I don't think it is. Oh, okay.
Maybe too far out.
Yeah, I gotta do it again. Let's just get rid of it. And let's add it back in. There we go. So you saw how fast that happened.
Dead.
Well, this is instrumental in telling us about the early solar system. Had the Earth been orbited closely by more than one object, more than one moon, okay, we can see what would happen. The early Earth would have been rendered molten again, as the moon was destroyed by being inside the Roche lobe. The Roche lobe is that area around the planet within which a planet cannot remain as cohesive, because the differential gravitational forces on the planet would tear the thing apart as it orbits the bigger planet. There was a nice big collision out there, and then those particles are going to come back in and circle the Earth and hit the Earth eventually, and they're going to make the entire Earth destroyed, that is to say, molten. So, had we had a moon that was like, just outside the Roche lobe, and let's suppose it got bumped closer, well, this is what would happen. See, we would end up having had this happen now, and as time would go on, okay, well, what we'd find is that the Earth would return to normal. We'd have more collisions like you just saw there. And then the entire planet would cool once this was all done, once this process was done. and that would have left us with no rings. Now, if there was a moon going around us at the same time, all right, let's say, like the moon, okay? Now, the moon started out close and migrated away over time. All right, but let's put the moon out here, okay?
Mm-hmm.
Now, we put the moon out here, and now the moon's another gravity well that's acting on the Earth and on the particles surrounding the Earth. I just saw a little flash on the moon, so something's hitting the moon already. So we can
It's
do
amazing what time can do.
I know. That's the thing. Over time, okay, orbits and things stabilize, potentially. Not always, but sometimes. So by looking at this, it gives you a good idea that had we had another moon, say, as I've heard people say, did we ever have another moon? My answer's been, well, not really. Why do I say that? Because if we did, we'd still have something orbiting the Earth. Because not every particle is going to get destroyed and taken away. Yes, there's going to be more collisions over time. All right? But look, you still got some particles that end up stable. So you'd have like a mini asteroid here or there that was circling the Earth, probably inside the orbit of the moon. Yeah. But
No more Mercury.
yeah. Well, Mercury was a different simulation, wasn't it? Did I start over?
No, you didn't. You put Mercury close to Earth. That's what broke up, right?
Oh, yeah, you're right. And then we got the moon. Yeah.
Yeah.
So, yeah.
You just have a fragment out there staying in one place.
Yeah. We'll just... Okay. Right, so we have this. Now, if we were to put, say, Saturn's moon Titan really close to the Earth, Faboomba. Now we have collisions already happening on it because of all the debris. But I think that, as we move forward here, we see fragments falling back to the Earth. Titan's being pulled apart. You see that?
Mm-hmm.
Titan's inside the Roche lobe. Oh, but what's the moon doing? The moon is now saying, hey, who are you? What are you doing here? Get your butt over here. I'm going to kill you.
It's kind of weird how the moon sounds like Bill Clinton.
Hey, I did not have lunar intimacy with that woman.
It sounds like a Family Guy Bill Clinton, but nonetheless, Bill Clinton. Yeah.
Giggity. Giggity, giggity, goo.
Yeah. Titan is eventing.
That's it.
Did you want any questions from your chat?
If there's some, sure.
Sure, because this is the first time I actually looked over at it. What I'm going to do is I'm actually going to end the P&K stream because it's about 2 hours right now. So I'm going to end that stream real quick, and then I'm going to jump over to Mark's chat and give him the questions real quick that you guys post over there. So let me do that.
Yeah, those of you
So
in
ending on
P&K.
P&K, and if you guys want to go over to Mark's channel and to finish up and hear the questions and answers, go ahead. But as for P&K, we're wrapped. Thanks for joining our little hangout session, and we'll see you with the moon stream soon.
Absolutely.
Absolutely. Later. Okay. Stream done. Okay. Let me see here. Now, let me close this down. That way I can bring yours up on my screen here. Okay. Very good. All right. Now, let me jump over to you, to the Planet Destruction channel.
Okie dokie.
Okay, here we go. Let me scroll up.
How many people were watching in yours?
I was like 11 or 12.
Okay.
Vicky asked you earlier, can you turn on stuff like the magnetics on these planets?
Oh, yeah, absolutely. I'll show you that. That's pretty cool. If we go to Earth and we want to see what's going on with the magnetosphere, we need to go over to, I think it's under composition. You come in here, and we go down, scroll down, and we say show magnetosphere. And as you can see, we don't see it. Why? I don't have a clue. It should be showing us that.
But usually you would be able to see it.
Well, actually, yeah. I mean, you know what? I think that we have kind of affected this planet so harshly
I know, right?
that we've kind
let me
of
see.
destroyed it.
Tana had a question too.
There's the magnetic axis, but I can show the magnetosphere. Look at this. This is really neat.
Nifty.
Yeah.
Tana says, Mark, what would it look like if there was a binary star system with one of the stars being a Dyson sphere? Would a planetary system survive that setup?
Well, if a Dyson sphere is surrounding another star, then we would just have two binary stars, kind of like say, let's do this. Let's take our sun, all right, and let's put another sun out there in orbit around it. But now, if they completely covered that and completely encased it, then it would just be a dark body of the same relative mass orbiting the star. So if you say, could a planetary system survive that? Well, it depends whether a planetary system is actually, surrounding both stars or trying to be within the two stars. For instance, when you see these guys, their orbits, they come close to each other, right, as we accelerate here. So only planets that are in a habitable zone around these stars will survive for any kind of long term. Trouble is, we don't know.
That one just reversed.
Well, yeah, because it's
Great.
the paths. Okay, we have paths on. That's why. We don't know whether the gravity is. I'm sorry. We don't know whether the planet is going to be in a stable orbit. Now, how you can have a stable orbit is if we were to do something like. Where are planets? I want to add planets. Let's add a Jupiter. Okay, and let's add it like this. Okay, so now what we've done is we've added a Jupiter to this 2-star system. All right, and as we accelerate, if a planet if a planet can be stable in this system, then we'd see it, fall into some type of arrangement. Now, if it passes too close to the star, as this Jupiter did, then we notice that the 2-star arrangement won't work unless the planet could actually orbit the barycenter, that is the common rotation point, orbital point for the stars. And we would actually have to set up the barycenter and have the star as have that star as the have the barycenter rather as the main focus. And there is a way to do that, I think. But one of the stars would definitely just be dark. All right, and let's just we can simulate that by doing this. Let's remove one star. Okay, and then this star, of course, will continue in the same direction it was going before. Let's do this. So now we have a star going through space. And if we want to simulate a Dyson sphere, then all we have to do is take a planet like, say, the Earth, okay, and put it in orbit around the star like a binary star system. But then we can do a little trick. We can go to this Earth, and we can set its mass to be, let's say, 1 times the sun. Okay, so it's like the sun, all right? And now, here's what we got. We have this relatively dark object that's now circling a star. And it's our Dyson sphere, isn't it? This is our Dyson sphere. So there's another star inside this, okay? In our...
I had a Dyson sphere. It's a good vacuum cleaner.
That's right. It really is. So there you go. This is now our Dyson sphere, and within that, you can imagine there's a star in there. Now, if we were going to do this for real, then the radius would actually be, if we did the radius of Earth, it might be, or sorry, radius of the Sun, then we'd have to say that it's probably 5 or 10 times. Let's go 10, and it may make the star blow up. Okay. Oh, look at that. That's interesting. Yeah, go boom. Yeah, so this is a problem with these things. So let's try this again. What I was trying to do was to show you how we can actually have a Dyson sphere situation, and I went too high in the mass. So now let's do a sun. Okay. And let's add an Earth to this. Okay. Add an Earth at some distance. Okay, here we go. There's the Earth. Okay. And now what we're going to do is we're going to go grab this Earth and we're going to make it the mass of the sun. So we have like 2 star masses, okay? But before I do that, I'm going to change the radius of the Earth to, let's call it, the radius will be just about 75% of the sun's. Okay. Oh, and look what that did.
Boy.
Yeah, I turned my Earth into a pulsar. Yeah, that wouldn't happen for real.
Sweet.
Yeah, that is a pulsar too. And watch what happens when they go fast. They dance. Watch this. Yeah, it's like into space forever. What's interesting though, speaking of pulsars, you watch how fast we can make these go. The fact is, okay, sometimes pulsars flash literally up to 700 times per second. Yeah, that's a lot because it's going away. I'll be back, bye. Yeah, these pulsars are cool. And that's just a single hotspot on the surface of the star that comes around over and over again to the same place that we can see it flashing like a beacon toward the Earth. And, you know, these pulsars are probably about the size of, say, a neutron star, which is about the size of Manhattan Island, maybe. And just imagine something the diameter of Manhattan Island spinning 715 times per second. Now,
It's like a champagne supernova in the sky.
yeah. And the thing is, you would actually have to, if you were looking at that thing in the sky, you would wonder, how can that thing even be held together?
Yeah.
You know, but it doesn't fly apart because it has intense gravity. But so yeah, so I'm gonna kill the stream. I've been doing a lot. We did our show today on SkyTour Radio. We talked about Canada's contributions to the space program.
Oh, Canada,
Yeah.
your flag, it has a leaf.
And say, Papa Tooties. You know,
Yeah, sorry,
I
I don't know the words.
I like the South Park version of that better. But anyway, and we talked about the Canada arm, which is the Canada arm. It's the remote manipulator that's started on the space shuttle on the Columbia in '81, and ended up a variant of it ended up on the space station.
Sweet.
Yeah, and then on the end of that arm, they put Dexter, the special project dexterous manipulator, which was it's basically like adding 2 arms, 2 wrists, and 2 hands to the end of the mechanical arm. Dexter is very dexterous, hence the name. So that was really cool, and so we talked about that, and that was all Canada's doing. That was all the Canadian Space Agency. And when we finished our program, we actually finished with the Canadian National Anthem, which is kind of
I know,
cool.
now you got it stuck in my head.
I know. That's why Keith is doing that.
It's crazy.
Hey, Dave, how you doing?
Yeah. What's up, Dave?
And just
But
want
on, you showed up just in time, Dave.
you just showed up just in time for us to say I gotta go to bed.
Yeah, I mean, we were going to do this for an hour, and now it's almost 3 hours later.
Yeah, well, we did 2 over on your channel too, and then you know, a lot of people on vacation. July 4th's a tough time, so we figured, hey, you know, let's have fun.
Yeah, why not have a fun night playing in Universe Sandbox?
Yep.
And then back to the regular programming tomorrow.
That's right.
But, yeah. So thanks for hanging out, buddy, and crashing some stuff together.
Yeah, it was fun. We didn't crash a whole lot, you know. I mean, let's just do one more, okay? Let's take Mercury. Duh. Okay, and now let's
do one we haven't done.
Let's
do
take
Uranus.
Mars.
Let's do them all. Crash them all together.
I want to launch Mars at Mercury. That's all I'm going to do.
There you go.
I'll do like a glancing blow. Oh. Ooh.
And dead. And look, a little CubeSat for disclosure flew by.
That's right. There's CubeSat right there. Oh, it's a fragment.
A little bloody CubeSat for disclosure, eh?
Yeah. Boy, oh boy. Are you able to hear the sounds at all?
Yeah, a little bit.
Okay, because I don't know if that's going to come across to the chat. But let's do this. Let's put the Earth here. Oh, no, I launched it. No, wait, come back. Come back. Okay, let's not launch. Let's put the Earth.
No, Jack, come back.
All right, so we put the Earth here still, okay? That was nice and still. Now we're going to launch a, let's see, a random.
How come it won't let you launch people?
You know, I don't know. Let's launch a random asteroid at it.
Yo, you should make a plugin for this. Be like, okay, now we're going to launch a flurfer at Jupiter. Or now we're going to launch a nibtard at Venus.
You notice a nibtard has no brain.
You notice a nibtard has a bigger head than a flurfer.
Oh. Okay, so now
Aim it at Florida.
Actually, it's actually going to kind of go to South America.
Oh, great. Yeah, they got enough problems.
I know, right? But watch this.
Now you're going to launch an asteroid at them?
Yeah.
You dick.
Hey, be nice.
Hey, I'm just sticking up for the people, man. You're the one
know.
playing God over here.
Yeah, right. Hee hee. Well, here we go. So now this is going in there, and the last thing these people know is the name of this asteroid that's hitting them, and it's called Ubi or whatever it is.
Hey, South American people, I voted against this. I told them to hit Florida, but I can't control the man.
I can't hit Florida. I got too many friends there.
Todos los deals on mi Chile.
No parlez-vous français, señorita.
I can't really see because the clouds which where it's actually going to hit, but it's somewhere down there.
Yeah, so I'm going to slow it down because I want you to see. It looks so nice when it's a random asteroid. This is actually bigger than Yucatan asteroid for sure. Which was a member of the Florian family of asteroids. Okay. All right, here we go. And now, slow it down now to just 2 seconds per second.
Oh, sure, drag out their deaths.
Well, watch though. Watch what happens.
You know what everybody's doing on the ground right now. In Ronstown.
That's right. No, I don't. That's a little bug within the system. It actually makes the wrong shock waves initially, but they straighten out. But see that? And now from the side, you can actually see that there's
There's a little bit of a kaboom going on.
Yeah, there's some elevated particles. See them? See that? Hey, look at those particles. See them all?
Ladies and gentlemen, that's a complex crater.
Well, it will be definitely a complex crater, but look at the shock waves moving out now. This is a game changer for the planet. See all these things?
Goodbye, Hawaii.
They go up in the air.
Tidal wave coming your way.
Oh, mega tsunamis. Yeah. This would be
Or,
mega tsunami.
as the natives say it, tsunamis.
No. The
Tsunamis.
natives say, big wave.
Natives say, holy Oh, I mean,
Yeah, that's right. Shiza. Yeah, so anyway, as
me
these...
come to you, Oumuamua.
That's right. So now you can see that the Earth
Oh, dissipated. Look at
couldn't
that.
quite shrug off this impact, but now there's going to be fragments that come back down.
Yeah.
Yeah. And by the way, these artifacts, like you see that, these extra little things here that really
Little
aren't there.
Cheetos. Yeah.
Yeah, the Cheetos out there.
Little cheese balls.
Yeah, those are actually they don't present themselves when you're actually just running this on your computer. That only happens during streaming. So it has something to do with the streaming parameters.
Hmm.
Yeah.
Interesting.
Yeah. So now we accelerate it a little bit. And you'll see that we've got...
And back to normal.
Well, you're getting there. Yeah, this is crazy. So that's... It's not back to normal. It's actually a game changer. You know what we can do? And what this simulator does, which is really good, it simulates the effect of a nuclear winter so that the longer you leave this, you'll start to see glaciation again and glaciers forming and ice forming from the overall impact event. I mean, this is really, it's very, very carefully done. It's really well done.
4,025,600 dead people.
Only 4 million?
Maybe.
All right, well, let's do more. Let's launch
Now
Pluto.
we're under the galactic string. And dead.
Here comes Plutok.
Doom, doom.
And Pluto.
Ladies and gentlemen, we're going to kill everybody.
Okay, now who calls Pluto Plunto? Who knows that out there?
Plunto.
Plunto. It's a character played by one of the guys that played in the movie Step Brothers.
No idea.
Oh, look at that. Oh, that's
Pluto's like, that'll teach you to not call me a planet, jerk.
Yeah. Large chunks and major shock waves already moving out. Look at the size of those chunks. I mean,
The Earth are just blue chunks.
yes, Earth has blown chunks. That's right. That's correct. Earth has blown chunks.
Earth has blown chunks, and now we have a new moon.
Well, you'll see some of them get up in the air enough, and then some of them, when they re-impact the ground, they actually are going to cause some really serious devastation. Oh man!
Really serious devastation. You cannot run away.
Look at that.
And you're worried about the rainforest now.
Yeah, right.
Yeah, I know, right? But to see this would never happen because everybody knows Antarctica would just melt and put the fire out. Simple. Duh.
Unless it struck on Antarctica and vaporized all the water.
No way, dude. There's like 10 feet of ice down there.
Several miles of ice.
That's what I said, like 10 feet of ice.
Lake Vostok is below.
And there's like an
thousands of
army,
feet.
and they're guarding the ice wall so nobody can leave or like
Oh.
fall.
That's right, dude. I forgot about that.
Told you. It's about time you come to our side.
Ay. All right, folks. Destroying Earth is the last thing for tonight. So I hope
It's like it's like an evil genius's like plan night. I'll tell you what. Yeah, we're just gonna destroying the Earth. That's it for the night, guys. We've done enough.
That's right. I think. Okay, I think we should call it for the night. Yes, let's go out for pizza. My treat.
Has anybody seen Tinky Winky?
Yeah, he was right. He was right about. Well, let's see where Where was he? He was right about
I
here.
love that asteroid path because it gave me an underground lair.
He was right about there.
Also, one is a fort in a freaking volcano. Okay.
Is that so
What
much
was it?
to ask?
I just need an evil base in a freaking volcano. Okay. Or sharks with laser beams.
Lasers. All right, guys. Thanks for coming and hanging out. I'm tired. I'm going to bed. And
Yeah, me too.
And my neck hurts. So I will talk to you guys, and I want to thank you all for having fun with us tonight for a little while. Remember, subscribe to SkyTour LiveStream if you haven't yet, and to P&K Space Imaging. That's Keith. Thank you.
What the hell was that?
That's you.
Yeah, okay.
You're funny.
Why's it always got to be me?
I guess you're the one that does that. He knows that. I crack up when he does that.
Blame the guest.
Oh, yeah. But you're a guest on my channel.
Now.
Yeah, right.
Jeez Louise.
Yeah. Or maybe it was Louise.
Might be.
See?
Grandma's got the walking fart.
Yeah, that's right.
And we ended on a high note, don't we? We end it with professionalism. Or we end it with girl giggles, one or the other.
It's too late for me, man. I'm like,
Don't get me laughing.
I'm all punchy. It's like too late, man. This is funny.
Oh, come on now.
See, you know it too.
Yeah.
Oh man, you know it. Y'all's a mean some bitch, man. You're like doing this to me. You know, look at them particles still going. Okay.
That's what we call lingering Limburger.
Yeah.
All right.
All right, man. Hey guys, thanks for thanks for coming out. You're getting as big a kick out of this as me, dummy.
I am so going to do that at one of your talks.
Well,
just in the middle of it, just so you lose it.
We have now I have to stay a few more seconds to like let people know the genesis of what you're doing.
I'm not doing anything. I'm just sitting here.
Yeah, right. Okay.
Mm-hmm.
Keith. And when you laugh, it's sort of it's infectious. The problem is
don't blame it on me.
Yeah. Okay. Okay.
Started this.
Keith worked out a way to make it sound like somebody was breaking wind in like a muffled fashion, and so every now and then he'll come out with those, and for whatever reason, it just struck me as really funny.
See, this is what happens when you push us to our limits and we stay up too late and we stream too much. We absolutely lose.
And when you never got more than 12 years old or something, because that's like I don't know.
Hey, I told you at the beginning of the stream, nothing but dick and fart jokes. That's always gonna come back to that.
Wow.
Jesus. I mean, at least could have gave a courtesy wipe or something.
Yeah,
what? Oh.
Yeah, you're funny.
Are we still in the air?
Yeah, I'm afraid we are.
Is this thing on?
Yeah. Was this thing on? Dunk, 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 dunk.
And demonetized now.
Yeah, right. Yeah, well, I don't monetize anyway because YouTube. There's no such thing as monetize with YouTube anymore.
Yeah, not really. If you want a nice extra 45 cents at the end of the month.
Yeah. My son made thousands of dollars with Google and YouTube, and he was making thousands of dollars when he was 17, and it was because he did all that stuff on the YouTube channel. He did AdSense with Google AdSense, and he ended up having a channel that to this day they're approaching 20 million hits, and they're putting up just funny videos that they do. Now they write them themselves, and they do some really good, sometimes dramatic stuff. And the channel is called Juntex, Juntex. If anyone wants to go check it out, you'll see Clem Puckett there too.
Clem Puckett,
and he's really not that smart, Clem Puckett. Yeah, see. Well, and Clem Puckett was one of these characters exactly that we created years ago and matured over the years.
One barked.
You step on a duck.
Yeah, there's a couple ducks walking around here.
Yeah, and we had fun with Clem, and Clem did there's a game called Slender Man, and they did a new series of Slendermans called Slenderman in Real Life, because Slenderman was sort of a computer animated cartoon and game, and he ended up doing the Slenderman in real life. So they got people that look just like the Slenderman in a suit and a white mask over the face. Really, really well done. And Clem participated in the making of the Slenderman series, so it was kind of fun. Then
I remember seeing Clem on a boat.
Yeah, right. Clem did the. We took Clem to Bermuda actually, and Clem would actually go. Look at all these people here. So Clem would actually go. Clem would actually go all around the ship and like go places that people didn't expect. Like on stage while the ship's performers were performing. And by the end of the week, Clem was really well liked, believe it or not. And the performers on the last night of the cruise asked Clem to come up on stage and be part of the act. It was really fun. Yeah. So Clem had a good time, but some people actually thought that was really some poor guy that didn't have much going for him. But
sure as hell found that cruise though.
Yeah, that's right. That's right. And then and Clem had this little thing saying that he was like, and he did on Clem's own YouTube channel. He has Clem Goes a Cruising, and it's about Clem going to Bermuda, and he tells you how he stayed in the hold with the Germans on this ship, and he was actually down there hanging out with the Germans, and you hear German drinking songs in the background. It's really really funny. Oh, it's funny. It's like,
oh Jesus.
Yeah.
Yeah.
And Clem's dumb as a post. He doesn't know. He has no idea what's going on.
I've seen a smarter mailbox.
That's right. Mailbox would be smarter,
Jesus.
Yeah.
Oh, man. My eyes are watering.
I know, right? That's because all the noise you're making over there is accompanied with a smell that you've got to, evacuate from your house.
Hydrogen.
And methane.
Methane.
Yes.
Mr. Methane.
Remember him? I watched that guy pump out the Blue Danube with his butthole. It was disgusting. It was actually disgusting.
We watched that for like 2 hours. We were the most entertained. Like, forget Marvel movies, man. We're watching Mr. Methane fart into a cake like that. Oh, Jesus.
You know he went on America's Got Talent?
Yeah, it was the greatest thing ever.
It was the greatest thing because they like, as soon as he reared back on that table and he cleared his throat, so to speak. Oh my gosh.
He cleared his throat.
Yeah, they
like,
all of a sudden
you second. Let me clear my oh, I think I got it. And he was like so serious
and
about it.
He's British. He's British.
He's like, okay, now let me put my feet above my head.
Now this is a little ditty.
This is a little ditty I wrote while I was in the bathroom. Oh, jeez, man. Yeah, sitting up at Bill's house watching Mr. Methane.
Oh, yeah.
Yeah, you think it's all about science with us? Nope. It's all about farts.
No, it's not true.
2 hours straight watching Mr. Methane. Oh, jeez.
That's just what happens when things, unravel and we just have to entertain ourselves.
Oh, no, kind of like now.
Well, yeah, like now.
Jesus.
Yeah. But anyway.
Now my stomach hurts.
Because you're going on mute to laugh. That's why. I'm not.
No, I'm not. I swear. I haven't touched mute once on this thing. I can't believe there's still 9 people watching. Wait, okay.
They all want us to go away.
You know what? I bet you these 9 people fell asleep because it's just me and you being a bunch of assholes sitting here laughing at one another. If you're still listening to myself and Mark, just type you're still listening in the chat. Watch. It's going to be like, nobody.
Oh, I don't think so.
It's just us. It's just.
Well, I see participants. There's only like me, and you don't even show up. You're not even here anymore.
Yeah, I haven't typed nothing in the chat all night.
Oh, look at that.
Oh, look, Hemi showed up.
Good evening, Hemi.
Hey, Hemi. We were just getting. It's crazy that you just showed up. We were just talking about posy rears.
I'm gonna get banned.
Yeah, you know those posse rears, man. They some good skid marks.
Yeah. Okay.
Oh, great.
All right, well,
Well,
folks,
yeah.
you know, if you watch,
well, no, it's
folk.
well, okay, folk.
if you watch to this point,
Yeah.
I pity you.
Yeah.
Otherwise, I will talk to you guys later. And Keith
Don't
is
threaten us.
right, but we're closing down the stream now. So we had some fun Destructos. We had Destructo Earth, Destructo Jupiter, Destructo Saturn,
And
Destructo
giggling like a bunch
Suns.
of schoolgirls.
And then Keith ripped us all apart with some.
Stop blaming the guest.
Oh,
It's
look,
not professional.
Tana's still here.
Oh,
Yeah.
Tana's still listening.
Abel Joshi, he's still here.
They must be way behind. You have a 30-second delay, don't you? Yeah.
I don't know.
Because if they're just, I mean, sorry that you guys.
Keith can't even control himself.
They're probably like, I came here for the science, but I stayed for the fart jokes.
No,
My.
we had a lot of fun. It was
We
crazy.
have to end this before.
Yes, I get it. All right, guys. Thanks a lot. I'm gonna kill the stream right
Kill it.
now. Good night.
Kill it.